project-based learning on BIM with the case study on heritage building. And I'm going to call it the term historical heritage building information modeling, or we can say it's BIM. That's what the internet said today. Okay. Now I'm going to review about building information modeling. So in case there's audience that the first time to hear that about building information modeling, so you can catching up. Building information modeling is a process involving the generation and management of digital representation, physical function characteristic of building, and other physical assets. So maybe we know building information modeling is not only modeling tools, but a method that we can create a digital representation of the real building. So it can share information about drawings, specification, visualization, maybe analysis. The most important is schedule and quantity takeoff. Okay, and the power of building information modeling is the I mean informations. The good BIM model can include part and material-based information as well geospatial, financial, procurement, and logistic information. That's the main thing about BIM. Every element in building geometry are confined with the informations. You can set more information there, so we can use it for a lot of things like procurement is the most important thing. And I'm going to talk about building information modeling life cycles. Mr. Abdul, can you hear my voice? Mr. Abdul, can you hear my voice?
Yes, Pak Cici.
Okay, thank you. I'm going to proceed. Building information modeling life cycle is start in programming. At the first time is programming that we use like a conceptual design, and the model is start to generate more detail. The more people invite inside the collaboration, like architect, engineer, structural, mechanical, electrical, and plumbing. They contribute to more detailed design and analysis. And then after the design development, we are setting up documentation for the building, which our goal is to get constructor to get their bidding on it. And if they won, the constructor can start the construction simulation, the construction fabrication, construction simulation, and the logistic. And until then, the building is start to operate and finish and start operating. The BIM model is used as a tools to maintain the building, and then we step if it needs a renovation or if it needs demolition. So the same model will be enhanced detail and more detail at the time and at the stage of design. Now, if you talk about BIM level of detail, the BIM level of detail consists several level of detail with conceptual design phase at a level of detail 100. This level of designs is maybe a mesh, volume, quantity, square meter feet, how many floor, and then move to the state of schematic design phase is called L level of detail 200. So it's start to looking at what client want to see, designs, renderings, maybe materials, and then move to document and tender planning phase about 300 and 350. So the model is start to more detail, adding more detail so that the contractor can put a price on it, can bid on the designs. And then after this start in stage execution phase stage, it's called LOD 400. It's more detail again. There are a lot of information for the contractor to work on it, to the worker and everyone on site, like management construction, can see the detail of the building and check it. And in finish in operation and maintenance space at a level of detail of 500, whether this building is originally detailing in drawing as it built, so it can be a guideline or the blueprint to maintain it. Now I'm going to check at a bit more level of detail on the life scale detail. You can see my drawings, like conceptual design is LOD 100, 200, and detail design is on LOD 300, and documentations is LOD 350. Construction logistic, more detail again, and LOD 400, and finish and operation and maintenance in LOD 500. So this is like the detail on the life cycles. So now I'm going to talk about historic heritage building information modeling. It's what is called HBIM. Now, what is BIM? HBIM is historic building information. It's an extension of BIM tailored for historical and heritage building. It focuses on managing a document historic structure, maybe using a parametric object or model, created both current data and historical research. That means that we can do maintenance about the building, about historic building with the BIM that we know today. Primary use of case of SBIM include one, the preservation through a documentation. A project may substantially change history structure. The project team may choose to capture document and existing condition for archival purposes. Two, analysis. SBIM is a very powerful tool to understand underlying issue, like a structure or material decay. They cannot mitigate this data. Cannot allow an engineer. This data can allow an engineer to plan potential intervention. So before the intervention, we can see clearly what's the building's problem is, and then carefully start what intervention are best for it. And three, restorations. All major projects start with documentations. Restoration projects are not different. Once information has been archived in a visual manner, the project team can leverage an SBIM environment for planning, visualization, and execution restoration project within a data-rich content. So this is how BIM used. Management, preservation, and society can use many HBM projects to manage ongoing projects. So heritage building can be managed with this model, just like a new modern BIM buildings. There's a lot of more data to manage and easier to manage it with BIM application. Now I'm going to back to the BIM life cycle, but now I'm going to specifically show that where the HBIM is added. The HBIM is added at renovation status after the operation and maintenance, and in the level of detail of 500. So in the level of detail of 500, HBIM need more accurate detail to capture before it can be used. But the problem is none of the heritage building is produced using BIM. They're using a conventional method, manual drafting, and a lot of things. So with no BIM the implement in the heritage building before. So this you need to doing a data survey, taking a data from surveys to capture again the buildings and modeling it into the BIM model. Now, I'm going to talk about how is an HBIM environment created. The first is we need to collect data. The first part of the project will typically data collection. Technician or specialists will use the technology to take a digital detail of data with digital detail survey, where they're using maybe a photogrammetry or LiDAR to create a point cloud. They'll capture the building to a precise condition of the structure. And with the data, a team of model will going to create digital model of the buildings with BIM software. Maybe a larger, more intricate software will take more time documenting a simple one is more. Uh, Definitely, we need more time to model in this building. Even though we have a point cloud or maybe a photogrammetry, this still time is tedious. And then integration and viewer, the BIM modeling of history building can now be accessed. After the BIM modeling has been made, now like preservationists, heritage architect can start to working on documentation of the database of the building and start to uh, using the model as a form or canvas to start to documenting the era of the building, maybe the damage, and then we're going to material analysis. SBI model may capture additional data such visually materials or the current conditions. This helps to understanding the decay pattern and planning restoration work and preventive maintenance. So you can use a HBM system to show this heat map or a point where the wall is decaying or there's a apa there's a water damage, water leaking or something in the building. It can be noted as heat maps or heat points, right? And then we're going to talk more down inside the data collection. The first thing we're trying we can do the technical from with a photogrammetry. Maybe friend audience were familiar with photogrammetry. Photogrammetry is a technology that delivers a 3D image of a source by combining multiple photo of it. You can complete the process using picture taken with anything from handheld smartphone to drone to the camera shot and processing by photogrammetry software. With there's so many factors taken into account, primarily the camera focal length, lens distortion, and resolutions. Position and angle camera when shooting object as well as having sufficient field of view of camera overlap between the photo of ejection area. So this is the drawing about explain about photogrammetry. Basically, we take a lot of picture that overlap each other to generate a distance within the two pictures, just like two pictures, like our eyes. Within our eye, with two eyes, we can measure distances. So that's why photogrammetry. Uh, that's how photogrammetry works. They're combining two pictures with overlapping, so you can get the data of the spatial data about distance of the building, form of the building, so you can get a 3D module of point cloud of the buildings. Now this is another example of photogrammetry. We can use it by handheld camera and walking inside the room and start to take a picture. Or we can use it a drone. Using a drone is more detailed and more accurate because drone have a GPS that state where the drone where the picture is taken and coordinates. So it can be more accurately capture the object. But drone cannot operate it inside the building. It's good for capturing a building from outside, from above, from the front. Okay, and then this is another method for data collections. We're using a light detection ranging LiDAR. Light detection ranging is called LiDAR, is a remote sensing technology that we use laser light to create 3D models of real world. It works by sending out laser pulse and measuring how long it takes to them to reflect back. Just like meter laser distance metering, but it can spray a lot of laser all the way, so we can capture a lot of building in one positions, a lot of scene in one position. Sorry. This is the graphic that's showing the LiDAR walking and scanning the building. And after that, the scanning process can be take it to the computer. We can get the scanning results and see it on the 3D. This is an example of the LiDAR working on the buildings. They can capture everything, like just autonomous car that scan the roads, so you can know where's the road is, where's the people and the building. The 3D object is all automatically captured, and it's very fast and accurate methods. Now I'm going to see whether it's using LiDAR or photogrammetry. They are both produce point cloud. Point cloud is like a sand, a piece of sand that creates a building. It's not a solid object. It consists of point that LiDAR and photogrammetry capture from the building, and it also take the color of the. So point cloud is collection of data point and a 3D coordinate system that represent the surface of an object area. Each point in a point of cloud is spatial measurement on the surface of an object, and the collection of point representation the entire surfaces. Point cloud created using maybe a 3D laser scanner or photogrammetry technology. The data point are collected in XYZ coordinate. The data can import to CAD software, visualization, design, engineering, and construction. Point cloud can be stored in variety format, including SG or LESS. We're using LESS for now, and other formats. But the downside of this point cloud is we need to have a LiDAR instrument or maybe a photogrammetry instrument and the software to do these methods. That this method is the instrument is quite expensive, and from small from independent atau small consultant is a little bit pricey. This is a model creations. After the point cloud is setting up as after we get a point cloud as a reference to BIM process, we can creating a BIM model from point cloud data. Involve using a point cloud data as a reference to draw, and model is different element of the building. The BIM model can be created in either 2D or 3D depending what we require. So after we basically we use the point cloud to generate the building. We draw, we modeling, we remodel the building based on the point clouds. Okay. Now I'm going to show the another option of data collection. This time is more cheaper. Maybe as a student, it's more affordable. It's using a SketchUp formats. I'm going to ask, is audience familiar to software called SketchUp? Can someone answer? Yes, familiar? Yeah, SketchUp is very easy to model. And how many of the audience that know in SketchUp have a photomat feature? No, no. Is there anyone know photomat's feature on SketchUp? Okay, yeah, just little people know about the feature. What SketchUp Automats do is the match photo tool in SketchUp allow you to match a photo to a model or drawing a building based on a photo. So we can recreate what LiDAR and photogrammetry using more cheaper tools. Just only take a photograph of your buildings, and we are SketchUp Automats will have a tools to align the X coordinate and Y coordinates and Z coordinate. So like the drawing at the top of drawing is a photo of the building with alignment of red lines representatives of X coordinate, and the green line representatives of the Y coordinate. Also the blue line representative of Z coordinate. So after that, we doing some modeling directly. not like a point cloud. We are waiting for scanner to achieve, and then we are creating a point cloud. No, but in this SketchUp Automates, after we align the photo, we're doing manual modeling with SketchUp. And then after the modeling complete, we can uh, capture the windows, door, and the material through inside our model. Next pictures, I'm going to see to show you how the SketchUp Photomats implements. This is a building of Yuki Taxi in Medan City, and what is the remain of it? Maybe some of you familiar with it. Uh, I'm going in this picture. I'm going to take parallel photograph of the remains, and then I'm going to import it to SketchUp Photomats, and after that we take alignment, and not in small time modeling we can achieve the SketchUp modeling with the material on it, and we can use it to capture the damage of the building. You can see the windows is missing, and there's a lot of thing about the ranks, and the rooftop part component is missing. You can see it in modeling. What it means if we modeling, then it means that if we can modeling, we can measure. We can measure it. We can use it for quantity takeoff or for procurement to manage how much we need to take to repair this building. Okay, I think this is the cheapest way or the low technology way to capture a heritage building that we can use to skip to make the data collections. Now I'm going to talk after the data collections. We have setting up. We move to integration and viewer. That where this part is the BI model of street building can now be accessed. We have on the model it, and also we can share it to a stakeholder. At this point, the preservationist or the heritage architect can start adding historical document to the database. Imagine this model is on our laptop, and we can click on it, and the wall or the windows or the doors and everything inside the modeling can be name it, can be classified, so we can know this is a door is still original, or this door is maybe not original, or this door is broken. What kind of broken? Is it minor, intermediate, or fully damaged? That's why BIM comes in. And this model is starting like a new building with BIM uh, model. The 3D model is consists of BIM software like Archicad will provide I'm sorry, the BIM software like Archicad and Revit provide classification and custom data to input specific kind of data such as renovation status, maybe a type of material that used, and can arrange a schedule to present all the data. After we input all data, we end up with a lot of data. Then that BIM software can easily to manage it all. Okay, this is another example of a wall with many broken and damages over time. We can do some material analysis that HBI model may capture additional data such as material type of current conditions. Will help under our understanding decay pattern and planning restoration work and preventive maintenance. You can use an HBIM system to show this as a heat map, as I say earlier. So in this picture that we can call I mean we can measure all the decaying process, and we can check the square meter, how many square meter that we need to repair on this building, and it's collected on the data on the right side. What kind of damage, what kind of preventive maintenance that you take, to finish it, you can there's a lot of thing in data. You can imagine heritage building will have a lot of place to repair, a lot of item to repair, and you need to a software to manage all. So I come with conclusions about HBIM. Now the HBIM offer a rich benefit, but can seem daunting to those who never worked with BIM before. I see that many of my students are working with application like Revit and ArchiCAD, but not using BIM potentially at full. They're only using BIM is for modeling and documenting, but instead of that, BIM is more than that. BIM is more capable from collecting data, programming, using a zone. So HBIM will going to be heritage building with BIM will be more manageable. And then the accurate data collection and modeling can be very time consuming. Yes, indeed, BIM not make it more easier, but every time we're modeling something and then we need to input information on it, the process will be more stretches, more long, more time consuming. I mean, so process of data collection is very time consuming. Yeah. And then older building might have undergone undocumented alterations over the years, so we don't have any benchmarking to know whatever renovation have been done in this building. So we need another information like as-built drawing, or the record of the repairing on the buildings. And BIM software and required tools such as LiDAR drone can be difficult to set up for small organizations. That's what I'm talking earlier. LiDAR will cost about 60 million and pricey. Maybe campus or apa have tools on it. But if not, there's also option like for SketchUp Automats to use. Okay. And BIM's ability to organize data and provide schedule will facilitate the procurement process for historic building and project. This is true, and this is very helpful. Okay, that's a conclusion for today, and I think that's all what I can present for the heritage building, and I think we can start from to discuss this. Mr. Abdul Rahman,
All right.
taking it up. Thank
Thank
you.
you very much. Okay, so ARCC, you're supposed to give whatever how you give
Yeah,
it.
there is architect, man. It's architect.
Yeah, architect Chichi, you're supposed to give 1 hour, but you give 30 minutes. That's very quick.
Yes, I don't have the problem is this too much 2 hours I think it's too much for presenting this thing.
Okay.
I think we
Yeah,
can
right.
start with a question and ask. It's more very informative.
Okay, so yes, correct. We should go for questions. Is there any of us, the students, to ask anything regarding this not new technology, but very tedious work, but it's for the better good of the future? So any of the participants would like to ask question, whether in the chat box or better if you want to communicate directly by asking your voice through your voice.
Yeah, maybe I can do some demonstration too, Mr. Abdul Rahman. So
Sure. If you want to do demonstration,
going to
please proceed.
And it's open for questions, so don't please.
So during your example, you can receive questions, right? Okay, sure.
So it's more informative thing.
Yeah, okay. You can raise your hands up, or maybe, you know.
Can you use my screens?
Yes, Pak.
Yes, this application like this is SketchUp applications. I'm going to tell about the methods I'm doing from photogrammetry.
This is called superimpose, right?
Yes,
I mean,
superimpose. This is the result, the end result of the photo. We only take one photo. This photo is straightforward photo and taking, but I'm using some meter distance here, so I can measure the. So I have identified measure of the. Let's say it's a door. Door's about 2 meter high. So what I'm going to do is
I'm curious, if like this picture is taken live at the site, right?
yeah, this picture taken like right with a scale bar on it, so we can we have the measurement.
Usually, I would tell my students if we want to do this kind of estimation, we will like to have a person, an actual person standing at the door.
Oh yeah,
Yeah, instead of
it's
that
kind of like that,
SketchUp person.
more accurate.
Yeah.
So the first thing is you said it's new Matt's photo is on the camera and Matt's new photo. This is where they started. We match new photo and then we start to put the photograph that we take before. I'm going to navigate to like this one. And then we get some line like blue line and green lines. The lines is a representative of the coordinates. So I'm going to set the red line here. Can you see my eye moving red line?
Yeah. Yeah.
Yes. Okay. Nice.
So this one is built in with SketchUp plugin, is it?
Yes. It's not a
Oh.
plugin. It's directly on SketchUp.
Oh, okay.
I'm
It's a
going
long
to
time I haven't used SketchUp.
every time I'm going to line is affecting the camera point of view. So like this. The angle is start to measure. Okay, I'm going basically is a putting camera guessing what aperture the camera use, field of view that camera is used. And then after we finish, we are measuring this wall is about 1.8, then we can adjust it to the buildings. Okay. And then after that, so let's open this Yuki Taxi. And after that, we can press the project texture from photo. So it can project what relies on photo after it get models. And then we rotate it. Then we have it a 3D model of the buildings and with the texture projected into the buildings. With these projections, you can see that I already made some modeling about the damaged building here. And then we can use it for more detailing damage. Example for this building. This is a standard using Archicad with a freehand tools. And then we can push and pull. Therefore, we can get the building model with the current situation or current damage. Okay, like this one. There's a hole in the wall. If you can start to set it like this and identify it and classification it on this damage one, and we can see after all how much damage this is and what treatment should be done with it. It's maybe like very easy now, but we can do this on more BIM software. I don't say that SketchUp is not BIM, but SketchUp have limited procedure on using BIM like quantity takeoff and scheduling. We can also import this building to ArchiCAD. I'm going to move to the ArchiCAD windows.
Yeah, before you move, there's a wondering question from me.
Please.
Do you came across measured drawing?
Came across the measure drawing.
Yeah, the knowledge of measured drawing. You know measured drawing, right?
Measure drawing of well,
It's where an undocumented buildings like old buildings where people come in and they measure on site.
You think of measured by hands?
Yeah, measured by hands.
Yeah.
So I'm asking you whether have people integrate with BIM system with measured drawings data. Like I know it's a tedious work to measure the building by hand.
Measure
It's more accurate, right?
this is one of the other methods that's very tedious. Yeah, very. For example, this building I only measure this height. Can you see my line?
Yeah, yeah.
I only measure only this height to get
Oh,
all the data. So it more faster. I'm going.
yeah.
You see a stick right here. You see a shadow stick.
Yes, yes.
Yes, my measure tools.
Oh, I see.
So with this stick, a 2-meter stick, I can develop this model, all model, very accurate. So we can know how much opening of these windows, and it's right there. Just like so we don't have to climb out there and measure it by hand. Yeah, it's very dangerous. But we only have to use one scale to measure all of it. That's
just a question, not saying that measuring is better. I'm just saying that whether have you came across people integrating measured drawings data towards BIM?
yeah. For more detail, the hand measure is still used for
I see.
measuring data or for the confirming what the we could.
So it would be depending on the detail of the thing that we want to do, right? If this is just a plain wall, right? Or how about a timber construction?
Yes.
So yeah.
But if we use this data collection with LiDAR, it's more accurate.
Oh,
So
like yeah.
uh, people do not use measure again, just measure another a few
quicker and
for
faster.
sampling the
Yeah.
corrections. But this process is more photometry is a process more cheaper. If a college or a student can use it for small projects, and
I
you
see.
think it's very accurate.
Okay.
Okay, we can only export this on BIM like this. I'm using ArchiCAD for the BIM main software. It's like I'm going to share. And can you see now the BIM the ArchiCAD pages?
Yeah.
Now this is the same model that we talked earlier.
So you save that in SketchUp and then you import it in here?
Yeah,
Okay.
I imported SketchUp for the capture only, and then working on the detail quantity takeoff using this material. I call this UV taxi, and then we can see the schedule come out from it. Maybe a wall schedule. Sorry, it's not connected yet.
This
Yes.
should be auto-generated, right?
Yeah, this is auto-generated. It's automatically calculated the area of the building, area of the wall, the damage and everything. So there's a lot of the damage of this building, you know. There's another photo. Maybe I can show you some other photos. So you have a image. You can see. Yes, can you see the photo? Yeah.
Yep.
Can you see this another photo?
Yeah.
Yep. This building is almost entirely losing its plasters, but still remain intact. Some buildings are deteriorated and there's a vegetation on it growing out and damaging the building. So we can imagine how much data about renovations will be occur in the process. We can do it manually with writing on it or with Excels, but it's going very tedious. That's why we at VIM with VIM applications come to manage it. So it can be we can see clearly what we're going to renovate, what is existing, what is need to demolish, maybe, or maybe what need to be created by new, if it's a preservation or conservation, maybe. That's maybe Mr. Abdurrahman the sharing.
Okay.
Uh,
When I learned in Australia's
mm,
university, they did a subject regarding to heritage, which is more to conserving the stuff, and also Australia country itself practices the heritage law where you cannot build or demolish a certain part of the building with the years of the build. Like if it's more than 10 years, you cannot, disrupt the heritage value and such not. Even so, if you want to build something on it. So there are a lot of buildings in Australia where they refurbish the actual building. Like my university itself, the branch university in DK, Geelong. So the whole building was supposed to be like a wool factory where they process wool, but they change it into a school architecture. So yeah, that's just my experience of knowing about heritage values too. But this one is in another level where you integrate technology, right?
yes.
Okay.
What kind of approach that they use to capture the building, Mr. Abdurrahman, at your in Australia?
I didn't learn how I just learned the part of where they are very particular about heritage. Not towards how they do it, but they're implementing that in Australia. We maintain heritage. That's all.
Yes, yes.
Yeah,
Basically we are an architect, yeah. We not
yeah,
develop a new buildings, but we are preserving it
yeah.
because it's architecture.
You should know better. You are a professional architect.
Yes.
I'm just a lecturer. Okay. So students, we already have an example of how. Okay. Apart from iCAD, what other softwares do you use, architect?
Okay. I'm using a BIM for the manageable, for the building, for the modeling, and then doing a pre-comment or the detail engineering drawing is all in BIM. But before that, using a lot of software and plugins to use. And for example, if we don't have plugins, we don't have any plugins, misalnya like in SketchUp, we need to model something that we don't have plugin. We're searching for plugin and no one created.
Mm.
So we created by ourselves. We created
Mm.
by uh, uh, creating a certain program. Yeah, I'm using a Rhino and Grasshopper
Oh.
to created a custom plugin or custom parametric design to achieve what we need to be made. It started me thinking that my thesis is about how if we are architect like you and I, Abdurrahman, Mr.
Mm.
Abdurrahman,
Yeah.
are we going to be limited by a plugin or a
course not.
computer programmer waiting to start a new program.
Yeah,
Are we design is only limited by that, or we can exceed that by we can do programming by ourselves. So we can
yeah, sure.
tools what we need, whatever tools we need, we can create it. No wait for the computer programming.
Yeah,
Yeah,
nowadays there's AI, right? There's ChatGPT and stuff.
that's more the powerful program that we use is Rhinoceros and Grasshopper.
See.
The software can do that, can do a visual programming.
How about Revit? Do you use Revit?
No, I'm not using Revit because it's kind of
Complicated?
costly.
Costly. Oh yeah, because you're
It's
practicing. Yeah, for students who have like pirated software, then they can use that. Not for
yes.
project purposes, but it's for
For
just
students,
yeah.
by Revit or ArchiCAD provide a free student license.
Ah,
ArchiCAD, my students call me and I call the Graphisoft and please uh, uh, give my students some license and they will give it everything. Every time it's okay.
I see. Okay,
And
we have a question from Nazla.
just like,
She wrote it in the chat box. I think Nazla, how about you
yeah,
you ask personally? I think it's better like that
I'm doing
because we
this.
are all human. Nazla?
Yes.
Yeah. Proceed with
Okay.
the question, please.
Okay.
Where is Nazla? Can someone pin her to the you cannot see her.
Thank you for the presentation, but I wanna ask, based on your experience, how accurate is the SketchUp Auto Match to use? And is it efficient for the photos building like the second image you show?
Please repeat the last one, the last question.
Is it efficient for the photos of building like the second image you show?
The one that you showed with the perspective, was it?
Ah,
Oh, boleh Naza pakai bahasa.
yang gimana maksudnya tadi?
Gini Pak, tadi Bapak ada tunjukkan foto yang kedua. eh Naza lihat agak crowded gitu Pak, mungkin banyak ketutup pohon. Terus view perspektif dari foto itu kan beda dari yang pertama gitu Pak.
Ya, lebih vegetated.
Apakah itu efisien kalau kita pakai SketchUp Auto Match?
Yeah, okay. Now I'm going to talk about the accuracy for now. The accuracy is come in like 5 centimeters. I can say 5 centimeters, depending on camera, what you use camera. More resolution and more higher resolution camera will capture more accurate the model. Slightly phone camera will capture maybe less than 5 centimeters. And it's quite accurate for starting up in here for small organizations or small consultants working is okay, maybe. And then another photo, I'm going to show the photo again. There's a lot of photo with vegetations cover. Share screen. Like these ones. Now we have we cannot we cannot modeling what we cannot see. That's a problem. So we need to clear the vegetation first and set up a photograph, or maybe we can set up a photograph and we estimates what behind these tree lines, because we are visiting the site, so we can know what appear behind the tree line or the coverage. So maybe to have a good accurate beside this photo, you need to come to the site and check it on by yourself and check it every site by yourself. That's to consider is to apa to mendapatkan gambar to get information that covered by vegetations.
More picture, more data. Yeah.
Yeah.
Does it answer your question, Nazla?
Yes, thank you Pak.
So make sure you take a lot of pictures.
Yes, that features and visiting sites.
So you get Nazla, you're gonna go Are you offline student or are you gonna be online student? Offline student.
Yes, offline student.
Okay. Okay. Okay, is there any other questions from the participant?
Okay, as additions, this is Yuki Taxi. A lot of this Yuki Taxi we cover from the photogrammetry. There's a photogrammetry photo about this, and because it's lost all resolve, the drone also capture all the spaces inside the building because it's unroofed and unblocked. So the method of photogrammetry using drone is, I think, is the second cheapest methods. The first more costly method is the LiDAR. So
But the drone can capture the plan view, right? I mean,
yeah,
the plan, yeah.
the plan we can capture it by drone because the
Yeah.
road's on.
Agree.
And the drone is not too expensive for now, about 7 million rupiah or 15 is affordable for now.
But
Maybe
those cheap drones, the cameras are not that.
uh, the camera
Right?
is pretty good. I'm going to say some major brand like DJI. I'm using
Did you?
very low DJI series.
Oh, DJI is expensive.
Yes, but it's produced 2K video is
Oh,
okay.
yeah.
It's very good. So maybe it come for intermediate user can using the drones.
So just an input for the students. So better if you want to take picture of a facade, you have to take a non-perspective view, right?
Yes, the best two times orthogonal view from front or a diagonal view. If
Diagonal view.
capture a diagonal view in this like these photos, or maybe share this ones. Can you see the view? This is right directly for photo.
This is the facade photo. Okay.
Photo, so we can align the x coordinates on the bit.
Oh,
And the y
axis.
coordinate is vista through the building. It's okay. We don't have it, but it's okay.
Oh, a vista view.
Vista is the y coordinate.
Uh-huh.
The
And the
x
Z?
coordinate is line between the windows and doors. It says you can use it to capture the building, and you also can capture it on like this one, like diagonal. So in the diagonal, you can see two of the lines, the X and the Y, like this one. So as long as you can fit the X and Y coordinate, you can capture these buildings. More about the how the photogrammetry use is you can see a lot of YouTube the tutorial you can see it from there.
Okay, very good input. Anyone else wants to ask question? I believe there's one of my students that likes this technology, Muhammad Faik. But is he in the participant here? Is it Muhammad Faik? Is he here? Danish? He's together with us, right? Faik.
Wait,
Faik.
I'll check.
He's my student, so I
Okay.
know that he likes this
Can
kind of stuff.
Yes.
But I'm not sure he's here or not, or maybe he's sleeping.
I don't think he's in.
Okay, but he's one of the participant, right?
Yes. Yes.
Yeah, he's one of the participants.
Okay.
Online participant.
Nowadays the students nowadays more very canggih ya, very
Okay, yeah, advanced.
advanced. I don't have any doubt with their apa ya competency about learning tutorial. They're very fast learning. Yeah.
Okay, just to remind the participant that you will be having to draw the Radhuis building.
What is his?
After at 10 a.m. At 10 a.m. The next session, that they will be drawing the Radhuis building, and the key pen will be given to them.
Oh, the Warren Hess meeting, yeah.
Yeah, so that's why you need to ask questions to our panel today, architect Chichi, so that when you want to do this task, you will do it without any problems. So it's quite important because you have an activity after this, how to do it using either Revit or whatever application that you are familiar with. So you only have a reference of a picture that's been given to you, not going to the site for Malaysian students. So I'm not sure if you guys are worried, but better ask.
Yes.
Unless you are pro in BIM system.
Okay. Actually, this Yuki Taxi building is positioned next to the Warren Hills building. As you see this picture, the Warren Hills building is the building on the left. And there's some quite the first mall in Medan, the first shopping store in Medan. So, and Mr. Abdul Rahman, can I ask what the Malaysian student given to for the drawings on the picture, or
When you mean what they're going to learn about drawings?
what the Malaysian student given from the ICA for the task?
I think the same thing. All of them have to draw.
Oh, okay.
That the moderator said to me that they will draw the RAUS, how do you say, RAADHUIS, that one.
So
all of
what's
them be
the
given.
raw material that they given it?
I think they're gonna give pictures.
Pictures.
Same,
Okay.
yeah, same like what you're practicing right now.
Oh, okay. But they don't have time to measure on field?
Not today.
Not
Not
today.
today. For those who are gonna go
Yes.
to Indonesia, maybe they'll do it hands-on.
Yeah, it can be difficult to using photomatch without paper measurement on site. Yeah.
Maybe it's just to make them experience how they do it. Yeah. If it's hard, then it's hard because they're not there, you know.
Not accurate, but not proper. It's possible to calculate to estimate the measurement.
Agree.
So
Any other students wanna ask away before we go on to the next session? I know it's quite early. It's like 1 hour early. I think the MC should be prepared for. We're gonna have early break.
yeah.
Maybe they can have time to explore BIM to those who have never explored BIM softwares.
Can I know? Can I ask about Malaysian student? What kind of BIM software that they familiar with?
Okay, so Malaysian students.
Yes.
Yeah, Razika, we want to talk about it?
It's okay.
Yeah, you can talk. They're not speaking behalf of Malaysia, but they're speaking behalf of the UITM.
Yeah.
So come on,
yeah,
Razika.
just from my experience, we first learned using SketchUp, but during my internship we learned Revit. So right now I have like 2 softwares going around, trying to learn.
The SketchUp and Revit, yeah, kind of the same like the student on Medan and USU. Revit is very popular. And I think it's in couple years. Archicad is the first BIM between the Revit, but Revit's more years and more advanced from now, more advanced from Archicad probably. But I'm using Archicad. It's like how I'm a teacher as architect in my student days. we're using line, we're using symbol. That's why ArchiCAD do it. So it's more familiar to me to use it, and more more the price is more good. This will provide one-time purchase software.
Yeah.
Yeah.
I have used Autodesk AutoCAD architecture.
Oh yeah. Okay. After this,
Okay, so that one they have we know AutoCAD, they produce 2D buildings, right? But when I use this AutoCAD architecture, it's different. It's like specialized in something, and we actually can do a 3D model. Just that is a bit special. It can produce a 3D. It's like Revit, but it's not too detailed in Revit, because Revit you can put the material usage and everything, right? But in AutoCAD architecture, they just to model it to become 3D. So that can also be part of the BIM. It's just that it's missing the details of material usage and the steel that's being used inside. So
yeah.
maybe you guys can use that too.
Yeah, from my opinions, the software is not the big thing. It's the procedure, the method. So the softwares can be anything. You can use it.
So Danish, you wanna answer the same question that
Yes.
architect Chichi was question?
Could you ask again?
You're not focused.
In Malaysia, there's architecture curriculum is to be an architect in Malaysia, you have to go on two kind of school, right? The part 1 and the part 2.
Yeah.
The student is the part 1 student.
Yeah. It's not one student.
Okay, and everything's going to everyone going to be an architect.
Answer that question, Danish.
Is everyone going to be an architect?
Yeah, we're going to part 2 and become architect.
In my opinion, I think majority of the people will go and continue with part 2, but it depends on each person what type what sector they want to be in. Yeah.
Yeah, maybe you want to be in this sector, the heritage BIM. It's quite rare in Malaysia, Danish.
Yeah.
Maybe me, maybe Faik or Razika.
Yeah, they can be a specialist. Specialist don't need to be an architect. Yeah, there's a lot of consultant that working on the specialist on capturing the heritage building. Or yeah, but in here in Medan is very very difficult, very not.
So in Indonesian syllabus, they learn this BIM system. Because in UiTM, in Malaysia, in UiTM specifically, not talking about architecture Malaysia, we don't learn specifically, I don't know for masters, but for the degree, bachelor's degree, they don't learn in depth of like Revit. They don't have a special class for Revit in the academic side. So when they want to go learn about Revit or BIM, they have to self.
Yeah. It's outside of academic curriculum.
Yeah, it's outside. Yeah.
Yeah, in USU in Medan, Indonesia, in USU particularly, we teach BIM on optional classes. Optional classes is not mandatory to.
Elective.
Yeah, it's like pilihan.
Okay. So
It's
you're the one who's teaching it?
Yeah. I'm the one teaching it.
Is there any mock or online classes that if the students from Malaysia want to join your class?
Oh, we don't have an online class right now, and it's very difficult to teaching online class for this practically use. But maybe we can do it for later. But
Yeah. Let me know if you have doing it for the USU UC. Yeah.
I find it hard to teaching on online with these subjects.
Yeah, of course.
Yes, yes. Okay. Okay, another one? Mr. Abdurrahman?
Pardon? Again?
Oh, it's okay, it's okay. Nothing, it's nothing. Is there anyone to want to ask? From USU students?
Oh yeah, USU students. Only Putri, Suci, and Nazla.
Yeah.
Let's switch on the camera. Every person is sleeping, I guess. Oh, there's a question from Putri. She's raising up her hand. Yes, Putri.
Hello. Good morning. Can you hear me?
Your connection is really bad, but we can hear you.
Hello.
Hello. Yeah. Just ask away.
Um,
Nothing came out. I think she lost connection. Yeah. Okay. Maybe you can type it in the chat box because you have poor connection. Okay. From the USU student, yes. Architect Chichi is requesting for you guys to speak up and contribute in the discussion.
Ya, silakan. Rekan-rekan dari USU, silakan. Bisa bahasa Indo aja kalau bahasa aja kalau khawatir.
Students will be students, right?
Yeah, it's difficult to start a conversation and
We have to add them in Instagram and
Mr. Abdurrahman, can I know I'm about angkatan apa ya? What angkatan Mr. Abdurrahman?
Angkatan Tentera.
What year you come in the bachelor? What year you come as
I was in bachelor's degree from 2007.
2007?
Yeah, until 2011, 4 years.
I'm in bachelor in 2000 and 2005. So
You're more senior than me, of course.
this is our generation is different from these student generations.
Yeah.
Very much different. So this student is more fast, very.
I agree.
They don't last reading books, a lot book. Maybe because nowadays we can see information from reels, YouTube reels. 1 to 2 minutes, one story, and slide pictures. You start a new story.
Yeah.
Yeah. So we make our generation part is very different.
But how come in the poster you look really young? In the poster, it's like,
yeah.
Oh, this guy is really young.
AI, maybe AI, using the AI. So. Yeah.
Okay. So Ishak or anyone else? Suci? Oh, itu apa? Maafin.
hello.
Okay.
Who's that?
Yeah, come on.
Who's that
Okay.
Pokemon?
I have a question, but
Can you introduce yourself first? Where are you? Which one are you?
Putri, but I have a low
Oh.
connection.
Okay, sure.
Okay. Based on the information that present to us, I am a Malaysian student. Specifically, in town planning student, and I am not really into this field, which is architecture. So my question is, we are not exposed with BIM modeling. We are using more AutoCAD, um, GIS, and so on. But modeling is not our part because it's detailed. So my question is, based on your experience as a professional architecture or architect, um, how did town planner in Medan or Indonesia collab with architect by using this modeling, or it just collaboration on social or environment? Yeah.
Uh, okay. I'm a little bit lost about the questions. Can Mr. Abdurrahman help?
Maybe what she's trying to say that from the participant in Malaysia right now in UiTM, there's two people, one from architecture and one is from landscape architecture. Sorry, town planning. So it's two different courses that's joining today. So she's saying that students from town planning is not familiar with BIM because they're not doing any modeling
Oh,
thing. So the outcome of that study, they don't do modeling. They just
yeah.
do town planning. They like urban developments kind of stuff. So that's why they want to ask you: is there in Indonesia that how does the town planning people in Indonesia integrated with architecture in Indonesia's field? So is it they do it together or?
Yeah.
Yeah.
In Indonesian, we call it town planning is perencanaan kota, gitu ya.
Bacaan kota. Yeah.
Perencanaan kota. Town planning is a different discipline from architect. Indonesian, we do too. There's two discipline.
But they're cousins, right? Yeah.
Yeah, no, I think cousin. Town planning simply set up how building codes, how building regulations, and we are architect. We cannot. We must agree with that. We must follow the kebijakan policy of the town planning. So our architect scope is more smaller than town planning, but more detailed. Town planning talk about kawasan, talk about area, talk about urban. Maybe town planning and landscape is like a sisters talking about kawasan without town, without urban. Town planning talking about urban city life and setting. But architect is inside under this town planning and landscape. We are dibatasin. We are limited by policy that they make. We cannot build something that already. If you have a site and on suburban, you cannot build 100% of your land. It's not it's against regulation of town planning. So how town planning is collab with architect? Yeah, town planning. BIM is we're talking BIM. We're talking of buildings and how the building is made. When we're talking about area urban, it's not almost it's not you all you don't have to be a BIM to generate urban places. Although if you using BIM, more data you can achieve, more data you can manage, but you don't have to. You can use only GIS, maybe conventional CAD drawing to set up. As long as you can calculate it all area and everything inside it, you can calculate it. It's okay. Then architect can adapting to that to this. Architect can adapting to the CAD and modeling and GIS. and the architect can export it inside the whatever BIM software that you use to detailing what the town planning asks them to do. Okay, I think it's that.
I think you can use BIM for town planning too, right? I mean,
Yeah,
it's
you can.
basically data and then just simple model, like just an outline of everything in the urban place, and then you just can put, I mean, not a lot of detailed data, but you can put data inside BIM. How about you try it, Putri? Okay.
But about
Actually, I've been trying this.
Again.
I think about the how town planning using BIM is the first town planning is setting up the area the apa policy, and then architect build the BIM, and the BIM is stored back to the town planning.
Yeah.
Like building regulation. In Indonesia, there is building regulation on the PDF. The PDF for the building, so the permit can publish, yeah. But maybe in Singapore or maybe Malaysia, they ask the BIM software, the BIM model to fill up the town planning data. So it's not the town planning who create the BIM, but the architect.
So they work together
and they collaborated again. So the town have a state of data of building BIM on it, and yeah, a lot of things can come up from it, like energy evaluations. We can calculate it how city energy evaluation by smaller beam that produce the energy, right?
Well, Putri just said in the chat box saying that town planner have been using BIM, but not as our main tool. Maybe you can teach the architect students to know how does town planning integrate with BIM. Yeah, that would be good to share information. Are USU student all architecture student or USU students that participate are all architect student or?
Yeah, I think they are architect student. Is there any? Yeah, I don't know. Is there any disciplines? But some is architect student.
So some of these are your students too?
Yeah, some of these are student. Nazla, is there ada yang lain? Ada dari prodi lain? Nazla, dari USU?
Nggak ada, Pak.
Yang arsitek aja ya?
Yes.
Only arsitek student.
All architect student. Oh, very good. I would like to ask someone to, have a talk with us regarding this matter.
Yes.
Anyone? Should I pick names?
Nazla.
Let me see. Because on the first day they all open camera, so I was weird. On the fifth day they don't want to open camera. It's like it's supposed to be on the first day you're shy, and then over the days you are not shy anymore because you already know each other for 5 days. So it's quite terbalik, opposite. I don't know. You can call your student architect.
Let me call. Nabil, is it Nabil is UAT.
Nabil is in UAT.
Siapa ya? Raufi, Syadak. Sabik sama Raufi deh.
Ada enggak tuh?
Nggak ada ini. They're not present. Amir Hafiz, UATM.
There's Patricia from Unica. Unica is which university?
Oh, Unica. Ada dari Unica ya? Patricia? Ada Patricia?
So Unica is not from USU. It's in Indonesia, right?
There is another university in Medan, Universitas Kristen Saint Thomas. I already teach sometimes there as a visiting lecturer.
And there's Laura, Angelica from Unica too. And there's two students from Unica.
Is there any student from Unica? Please.
And Novitelis Zaluku.
Yeah.
Okay, those names that has been called upon, please rise.
Ada Novitalis Zaluku ada? Oke, pakai bahasa nggak apa-apa.
I still can understand.
Ya, halo.
Halo ya, apa kabar?
Sehat, Pak.
Ya, mahasiswa Pak Taufik ya?
Iya, Pak.
Oh,
Kemarin,
kan? Saya pernah juga ngajar di sana several times. Silakan Pak Abdul Rahman.
Oh, hi, Novitelis. Your name's quite unique. So, I don't know what to ask. It's just like want to have interaction, you know. So, the only three of you
Dari Unika berapa?
from Unica?
Yang ikut berapa orang dari Unika?
4 orang, Pak.
4 orang.
Iya.
4 orang.
Oh, oke, banyak juga.
So, satu laki-laki, 1 cowok,
Ya.
and 3
Yes,
cewek.
Iya.
Okay.
Ya, Unika nih salah satu perguruan tinggi tertua juga di Sumatera nih. Oldest prodi atau architect department from.
So, what semester are you from? Zuluhu. Zuluhu is your father, is it? Ayah.
Novitalis semester berapa?
Semester 8.
Oh, udah mau selesai? Sudah ya,
Masih.
bagus ya.
Semester 8. So,
Yeah.
4 tahun architecture.
Yeah, in Indonesia is 4 years.
Oh, similar
It's
to
part 1 4 years and then part 2 1 year.
sama UiTM. 4 tahun.
4 years. Oh,
Yeah.
okay.
Tapi mereka dari high school, finish high school, habis
Yeah.
high school, and then 4 tahun habis part 1 kaki.
Oh, 4. Then part 2 2 years again.
Part 2 tu part 2 2 tahun pula.
Jadi
Oh, sudah mau habis
iya.
Yes, sir.
Tanya mau sambung master.
Oh,
Enggak
jadi-
perlu.
Masih belum.
Mau jadi arsitek, mau
Atau
perlu ada
jadi-
part 2 kan?
Arsitek.
Oh, jadi arsitek. We call it a part 2 is PPAR, Program Profesi Pendidikan Arsitek.
That one 2 years.
Is 1 years.
1 year.
The bachelor is 4 years. Adding 1 years, totally 5 years for international architect to achieve.
Then you become graduate architect.
And then you become graduate architecture student,
And
graduate architecture.
and then you can sit for professional.
Yeah, you need to mentorship for maybe 400 hours to 2 years for mentorship, and then ujian test license.
Jimat ya setahun. Di Malaysia 2 tahun
2
untuk
tahun,
part 2.
ya.
And then you sit for exam for LAM part 3. Then you can become professional architect.
I think is 2 years probably makes sense. 1 year is too short for a professional ini.
So you guys do recognition for RIBA?
RIBA ya.
Yeah. You guys are also recognized by RIBA? No, USU.
Nah, USU tahu riba? Organisasi?
Ada ke riba? Ada recognized riba?
Nggak tahu. Mereka Pak.
Oh, nggak tahu
Ikatan Arsitek Indonesia itu kan yang kami kalau LAM ini Ikatan Arsitek Indonesia ya, misalnya Abdurrahman ya.
Yang tu Malaysia pun ada. Dia ada professional body for each country. But this one RIBA is recognized if you want to work outside.
Ya. Kalau if Malaysians under RIB ya.
No, Lembaga Arkitek Malaysia.
Yeah, lembaga arsitek Indonesia under RIBA.
No. RIBA is a different. This
Oh,
is
it's
Royal
the
British. Royal
British Persemakmuran.
Institute
Yeah,
British
okay.
Architects. So it's like UiTM currently have recognition by Royal British Architect, which is from Britain, where they recognize if the student wants to work
Yeah,
anywhere in the world in Commonwealth countries
yeah,
like Australia, Britain, and they can go and work. It's been recognized by them, or maybe they want to further study from abroad. Even so, if they choose to come back to Malaysia to work, then they need to have that university is been certified by Lembaga Arkitek Malaysia.
yes. Sertifikasinya
It
by
goes two
LAMDIR.
ways. Yeah, it goes two ways.
Yeah.
Like I previously was from Deakin University in Australia, Geelong. So Lembaga Arkitek Malaysia also recognized that university as a valid courses and valid program. So when I come back to Malaysia, I can work in Malaysia as a graduate architect.
Yes,
Like that.
But in Indonesian, we are Ikatan Arsitek Indonesia under Union International Das Architect UIA. Like RIBA in Malaysia, we
I
are
see.
UIA. They kind of differ, but they have a commitment. They have for some, misalnya ada student from Malaysia working in Indonesia.
I see.
The UIA and the Ikatan Arsitek can convert their certifications so it can be state as architect Indonesian.
I
And
see.
then
Okay. Okay, nice to know. Very good information. Maybe you guys that want to go to Indonesia tomorrow. Tomorrow, right? The ones tomorrow you're going to go to Indonesia, right? Irshad, you're going to no? Nabil.
Yes, tomorrow.
Yeah, Nabil, Irshad, and is it Nabil Irshad? Yeah. There's four from architect and 4 from town planning. Okay. I think we can wrap up this session, right? Architect Chichi.
yes, sure.
Okay, so thank you very much, Architect Chichi, for the input regarding BIM, which is very simple to do, but effort to do the work of inputting the data to your own use for your own project. But for this summer camp course, which you would be implying this tomorrow, starting tomorrow, you have to go to the city that you've been assigned to collect that data. You have learned about collecting data like yesterday and the day before. And now that one is the what do you call that? Pre-process where you collect the data, and then for the BIM is where you post, where you want to do what's next, what's in the future. So it's quite important to know. If you just only have the pre-data but you don't know what to do with it, then it's useless. So you as an architect, mostly of you going to want to become architects, you have to know what are you going to do with that data. Is it just to see and just to admire? No, but to use it as for what? Okay, so and yet again, thank you, Architect Chichi.
Yes.
MC, could we please, we will be giving you a plague and an online certificate. So let's watch this for a while. MC? There's no sound. It's very quiet, the sound. Can you hear the sound? I can hear very low.
There's sounds.
Okay.
Okay, thank you.
All right, that's the ceremony for appreciation for you.
Thank you.
Okay, thank you very much, Pak Chichi or Architect Chichi.
Yeah.
And with that, please explore more. This is only just introduction for you to know about BIM, because nowadays technology are required for you to know about BIM because it's a demanding for working experience for working. Now I would like to give the floor back to the MC. Thank you.
As a token of appreciation, the International Summer Course Architecture 2024 Committee presented a plaque of appreciation to Mr. Abdul Rahman Kamaruzaman for moderating today's first session.
Thank
And we
you.
would like to take a moment to express our gratitude to Mr. Rahman, who has once again graciously served as our moderator for the first session of this International Summer Course program.
This marks the third time Mr. Rahman has taken on this role. Thank you so much for your continued support and outstanding service.
Mr. Rahman, your contribution is exceptional.
Thank you very
Once
much.
again, thank you, Mr. Rahman.
All right. Now we will have a short break until 10 a.m. GMT +7 West Indonesia time.
And we will explain about the individual assignment level.
All right. Have a nice short break.
Have a nice break.
pancur sisada melamering mo bagai turang alemar di dakalakmo bekel masada duan dando alekat di tapo duan dando alekat di tapo. Kita
All right, everyone. The internet break is over. Now we will give you some briefing about the individual assignment. So we will have 3 minutes to wait other participants.
Ask your friend, or you can chat your friend to rejoin the meeting, because we will have a briefing about the individual assignment. All right, so we will start the briefing about the individual assignment. So today's assignment is given to a rebuild for the X-rod heist. Yeah, so you're gonna remodel the X-rod heist. Next slide.
For the guideline, first, remodel the song file You may use any BIM software such as Revit, Revit, Vectorworks, Bentley, Tekla, and another software. And for the content criteria, export the file as a PDF in A3 size, and then the output should include the image of the first floor plan, second floor view, and for the third perspective, and for the rules, quiz on the second GAM and 10 a.m. until 12 p.m. This assignment is worth 5 points. Individual tasks. Upload your assignment to Google Classroom by 11:59 p.m. GMT 7. Late submission will affect to your score.
And this is the class code for those who not yet joined the classroom. The class code is SMWSYPW. Okay. Next slide. All right. Now you can start to do your assignment until 12 p.m. GMT plus 7 West Indonesia time. Then from 12 p.m. GMT plus 7 West Indonesia time, you can take a break and we'll start again at 2 p.m. for the lecture from Dr. Jeffert. And also don't forget to submit your assignment before 11:59 p.m. GMT plus 7 tonight.
And don't forget to see the next town hall, our quiz on the Google Drive that we have sent to you.
All right. Thank you, everyone. Have a nice break.
Have a nice break.
Okay.
akan mo pancur sisada melameringis mo bagai turang alemar di dakalak mo bekel masada duan dando duan dando duan dando aleka kita po duan dando duan dando duan dando aleka kita po.
It's 2 p.m. already, meaning our break time is over. We will wait for 3 minutes for other participants to rejoin this meeting.
ISCHA 2024 participants may turn their camera back on as a sign of attending the class and respecting the speaker and the moderators.
For the next agenda, we will listen to lecture about workshop on Geographic Information System or GIS.
But before that, let's introduce our awesome moderator for today's second session, Mr. Ahmad Mansuri, SD MP.
Mr. Mansur is certified architect at Triadiga, an architectural design firm in North Sumatra, Indonesia. His architect projects specifically work on hospital buildings, urban designs, and various architectural designs. In academic, he works as a lecturer in the architectural department at the Faculty of Engineering Universitas Sumatera Utara, affiliated with the Digital and Computational Design Laboratory as a lecturer and researcher.
He is currently pursuing his academic career as a PhD student in architecture at the University of Liverpool, focusing on parametric architecture, design algorithm, and digital or automated fabrication utilization in bamboo and Indonesian traditional and contemporary architecture.
To shorten the time, please join us to welcome Mr. Mansuri. Good afternoon, Mr. Mansuri.
Hi, good afternoon, everyone.
Mansuri, you may take over the meeting.
Good afternoon, everyone. Welcome to today's session on our second session of the 5th International Summer Course Architecture, Universitas Sumatera Utara. And now we are on the second session for today's event. My name is Ahmad Mansuri. I am very delighted to be your moderator for this session workshop event on the topic of geographic information systems. And as we all know, GIS has become an integral part of many fields in architecture, especially when it comes to providing a powerful tool such as visualizing, analyzing, and interpreting data related to geographic information system. As introduction, maybe I would like to starting that this topic has some intersection in our knowledge, whether it's urban planning, environmental science, urban design, or probably other application that this GIS significantly influencing our architecture practice in the future. And today, we have a very fantastic opportunity to probably going deeper or dive deeper into this fascinating topic. And I would like to explore with our speaker today on how GIS could be integrated in architectural topic and how it could support architecture and other related topic that could be beneficial for us today. So before we proceed to the main presentation, I would like to extend a warm welcome to our speaker today in this topic, Dr. Jabhat Daramola. As an introduction, Dr. Jabhat Daramola is a Nigerian academic and lecturer in the Department of Social Science at the Federal Polytechnic Bida, Niger State. And he also earned his PhD in geography from National University of Malaysia, or UKM, in 2019. Focusing on GIS application in river modeling and sediment yield assessment. And he has various educational background, includes degree from University of Lorin, University of Ibadan, Usmanu Donfodio University, and several other institutions. And his professional qualification also include certification in project management, disaster management, and healthcare data analysis. And he also has a professional membership in Nigeria Geographers and member of Association of Nigeria Geographers. And also Geoinformation Society of Nigeria, as well as Teachers Registration Council of Nigeria. And we are very privileged to have him with us today to share his insight and knowledge on this particular subject. And I would like to invite everyone to listen to this very interesting topic for today's session. Before we begin for the presentation, our session today we'll start with Dr. Jabhat Daramola's presentation, and then followed by the Q&A session after that, where all participants today will have the opportunity to ask questions and probably engage in further discussion. As a moderator, I encourage everyone, all participant to write down if there is any question that come to mind during the presentation. And alongside, you can also submit them via the chat box that already provided in the Zoom meeting. And without further ado, let's get started. And I will pass this session to Dr. Jabhat Daramola to start and deliver his presentation. To Dr. Daramola, the floor is yours now.
Good morning, everyone. I'm highly grateful to be one of you this morning, and I want to sincerely appreciate everyone for this opportunity given to me. I say good afternoon there in Indonesia, or good morning in Nigeria. I want to appreciate the Vice Chancellor for this great opportunity, the Dean, the HOD, and the coordinator of this summer program for giving me this privilege to deliver this lecture. Most especially too, I want to appreciate my good friend who recommended me, Dr. Lim, for this lecture. Thank you very much, Terima kasih. So quickly this morning, we are going to be diving into Geography Information System. And our objectives. The first objective is to familiarize participants with the basic principles and concept of GIS, including spatial data, layers, map, and geospatial analysis. Our second objective is to provide hands-on experience with popular GIS software, like the HackGIS, to help participants learn how to navigate the interface, manage data, and perform basic operations. The third objective is to teach participants how to collect, import, and manage spatial data, digitizing and editing data layers. Number fourth objective, explain various spatial analysis techniques, such as buffering, overlay analysis, to solve real-world problems. Number five is to guide participants in creating and customizing maps using symbology, labels, and cartographic principles to effectively communicate spatial information. And lastly is to explore how GIS can be applied in different sectors, such as urban planning, environmental management, disaster management, and architectural sector. So our table of content include the following: introduction of GIS, component of GIS, basic GIS principles, method of geospatial data acquisition, GIS storage and representation, GIS data structure, spatial analysis, advantage of using GIS, GIS application area with a focus on architecture, engineering, and construction, and then the heritage building preservation, and lastly is the GIS interface. So without wasting much time this morning, let's kickstart. We have been hearing the word GIS several times, and how does it come to be? We discovered a long time people study the word using different kind of models, such as maps and globe. In the last 40 years or so, it has become possible to put these models into computer. Packaging this model into smaller computer now help us to come up with what we refer to as a geography information system. Because these models, along with the tools for analyzing them, make up what we refer to as a geography information system. And therefore, I'm going to define GIS as a unique integration of computer hardwares, the software, the peripherals, procedural techniques, organizational structure, institutional framework, for capturing, manipulating, analyzing, modulating, modeling, and displaying geographically referenced data for solving human complex related problems. Human race has a lot of problems ranging from flooding, disaster of all manner diseases. So when we capture this information into system and then analyze them, model them to solve this kind of problem, we refer to it as a GIS. We refer to it as a Geography Information System. So there's no definite definition or specific definition of GIS. But the main thing is that it has to capture system and capture spatial and also involve human in order to solve this world or global problems. So in another definition, you can say GIS is a system to capture, to store, analyze, model, manage, display, represent spatial information. It's a means of representing data in a geographical form. Then quickly, what are the things that make up GIS? That's what we refer to as the component of GIS. What are the things that make up GIS? The first thing we have is the hardware. The hardware, which include computer, it can be your tablet, it can be your laptop, it can be your desktop. And then where you have this, that's the basic foundation to start GIS. Then we will have what we refer to as software. Software is a set of rules that carry out a certain assignment for us. So software in this context, we are referring to application softwares. And it ranges from simple viewers, which allow you to view but not create maps, to map creation software that can display in numbers of layers, to a more powerful application that can handle and display enormous amount of data. So when we are talking about software as far as GIS is concerned, there are three major things that GIS software must be able to perform. Number one, GIS software must be able to do automated mapping. GIS software must be able to perform automated mapping function. It must be able to perform data management function. GIS software must be able to manipulate data and must be ready to perform analysis. So these are the three major functions that make GIS software to stand out among any other softwares. So any software that cannot perform these three major functions cannot be regarded as a GIS software. And then the number three component of GIS is data. Data, of course, we have two types, which is spatial and attribute data. When we talk of data, we are talking of a raw acquisition of data, which can be in any form. So it is spatial data when it is pinned down to a particular place in the space. It becomes spatial data. And the characteristics of this spatial data is what we refer to as attribute data. For example, you are talking of maybe there's any river Indonesia, for example. River Indonesia can be pinned down to a particular point in Indonesia because it has a location. So it becomes a spatial data. Then what are the characteristics of this river Indonesia? River Indonesia will have volume, it will have length. So this becomes the characteristics of river Indonesia. That is what we refer to as attribute data. Then we proceed to the next component, which is skill or people trained to use GIS. We call them brainware. These brainware are the people responsible for the manipulation or the analysis of GIS. Because if there's no brainware, you have data, you have software, you have data, nobody to manipulate things, then GIS cannot function. So when we talk of skilled people, we are talking of you and I. who have the knowledge of GIS. And these 4 sets of components are the major components of GIS. They are the critical aspect of GIS, of which if one of them is missing, then GIS will not function. If any one of them is missing, GIS will not function. And then we have the next one, which is method or procedure. Method or procedure. That one refers to the approaches to create before starting any GIS class. The approaches to create. What are the things you need to get, you need to make available? Number one, we have organization, plan, and operation rules. How are we going to set up our GIS laboratory? It's talking about that one. How many GIS experts do we need to function in that laboratory? What kind of GIS software are we going to use in that laboratory? Database management system type that is required to function in that laboratory, and the standard of the output we are expecting. So when we are talking of this, we are talking about method and procedure. And lastly is the network. The network is WebGIS. This is not necessarily for any standalone computer, but this one become usable or applicable where we have GIS classes in different locations belonging to one organization. For example, now, your university there, maybe you have another campus in another town, then you link your GIS, the 2 laboratories in the 2 campuses, you link them together. That is what we call network component. And then we go to the basic GIS principles. What are the basic GIS principles? In everything we do in life, you know, you will agree with me, there's principles if you want to have the best of it. So GIS also have principle. And the first principle is that GIS map contain layers. You cannot separate city from country or country from the ocean on a paper map on a globe. When you have a paper map that contains country, it contains state, it contains river on a paper map, there's no way you can peel them out. You can't separate them. But when it comes to GIS, you can have a layer where you have the rivers, a layer where we have the lake, a layer where we have the states in a nation, and then you can separate them. You can study each one of them independently. So GIS contains layers. That's the first principle. The second principle is that layer may contain features or surface. Layer may contain features or surface. That is, the transmission line layer comprises numerous lines. The transmission layer, that is electricity layer, consists of numerous lines, and the basin layer may comprise numerous basins. The state and the lake layer have similar pattern with several similar types of elements found in each layer. A feature is any geographical entity within a layer, including states, lakes, transmission line, coal basin, and so forth. Geographical feature in a layer is referred to as a feature. Not every layer, though, has feature, unlike other layers. The ocean layer is not made up of collection of geographical items. When we talk of the ocean layer now, we are talking of surface, because it does not have a limit. It's an span. It's too large, so we call it surface. The same thing you refer to land as surface. Ocean is also a surface. So they are not feature, but surface, as far as geography, information system is concerned. Then the third principle is that features have shapes and size. Feature have shapes and size. There is an infinite range of shapes for geographical things. All of these, though, may be expressed as one of 3 geometric shapes. Is either the shape take a form of line, or it take a form of point, or it take a form of a polygon. River, we take line form. Highway, we take line form. And pipeline, we take line form. However, places like nation boundary will take a polygon. A nation will also take a polygon. And just a borehole point or electric pole will take a point because it consists of only one X and Y. So that is another characteristics of or principles of GIS. Then feature must have location. You must be able to pinpoint your feature to a particular space. That is to say, you must know the X and Y of your feature. As I am now, you can take my coordinates. So I can become a feature. Where you are standing, you have a coordinate. So you can become a feature also. Your school is a feature because it can be pinpointed to a particular space, a particular point in space. So that is another basic principle of GIS. Feature may be shown at various sizes. Features can be shown at various sizes. Feature can be shown at various sizes, depending on the scale of your map. Depending on the scale of your map. Features are connected to information. Just as I've said earlier when I was trying to define the difference between spatial data and attribute data. The attribute data can be linked to a feature. A good example is your university there. If you want to create attribute data for the university, we can, after getting the location where the university is standing in space, then we can now begin to collect the attribute tables, number of students, number of faculty in the school, number of departments in each of the faculty, number of students. This become attribute table. So you can link your attribute table to your feature. Then we go to method of geospatial data acquisitions. How do we acquire our data? We acquire our data through two special ways. And one of the way is direct data acquisition techniques. Direct data acquisition techniques means you go into the field with your equipment to get your information that you needed. You can carry your handheld GPS, you can carry your surveying equipment, you go to field and make measurement, you can carry your tape, you can carry your measurement tape, go to field, take measurement, and you record it directly. So this is what we refer to as direct data acquisition technique, and is also known as the primary method of data collection. Primary method of data collection, which involves field survey and using of remote sense images. Then we have another one we refer to as indirect data acquisition, known as secondary method. This is the use of spatial data collected earlier by someone. It's not done by you, possibly by others, and which involve the use of maps and available digital data. Though sometimes you have to pay for them because it's not your work. So, and in order to make use of this, you can capture them using digitizer, using scanning method, and global positioning system, GPS. Next slide. Then how do we model or store and present our data? GIS data model can be either in raster or in vector data model. Either in raster or vector data model. Raster is talking about pixel, that's picture element. And when we talk of vector, it's talking about single location, the analog method that we are used to. So all geographical feature on the Earth surface can be characterized. They can be defined and stored as one of these three basic features. Be it raster, be it vector, you can store them as a point data. And point data exists when feature is associated with a single location in space. And when we are talking of single location in space, we are talking of one X and Y. That is one point of longitude and one point of latitude. We give you a point data. We give you a point data. Latitude 20, longitude 15. That's a point data, just 1 point. So when we have this kind of a thing, we refer to them as point data. And Example of point data include fire, lookout tower, an oil well, or gas activity site, and a weather station. Then we have another one we refer to as linear data. Raster or vector can also be represented as a linear data. Linear data exists when feature location is described by a string of spatial coordinates. That is to say, you have more than one X and Y. You have series of X and Y. And a good example of that is river. The starting point of a river starts with one X and Y. As the river projects or progresses at bend, you have different kind of X and Y. So these are series of X and Y. Railway station or railway line, pipeline are good example of linear data because they have series of X and Y along their route. Then the last one is area or polygon. Area or polygon describe what we mean by a closed string. A closed strings. In the sense that when you go around, you come back to the starting point. That is to say, the starting point coordinate will appear twice. The starting point coordinate will appear twice. It will be at the starting point, and it will be the last point you also record. So in order to give you a closed polygon, an area. So those are the type of model, storage, and presentation that we have. Next. And this is graphically illustrated here. You can see the data structure, vector and raster format. Then on our paper map world, it contains just one single point for future. Then line, we have series of X and Y. An area, we have X and Y, series of X and Y that close up. That is return to the starting point. So point are stored as individual column and row entries as a matrix in raster or as individual X and Y coordinates in vectors. And lines are stored as a set of connected cells or as a set of mathematically connected X and Y coordinates. The same thing applies to polygon when they return to the starting point. Next. However, we must note that these things are not permanent. It changes depending on the scale of the map. As the scale of the map increases, e.g., when we have a scale of 1 to 15,000, increase to 1 to 100,000, the relative size of the feature decreases. It reduces, and the following thing may occur. Some feature may disappear, e.g., features as pound, hamlet, lakes become indistinguishable as a feature are also eliminated. Feature changes from line to point, e.g., village to town, represented by a polygon at 1 to 15 scale, may change to point symbol at 1 to 100 scale. What this information is just trying to tell us is that when you look at the world globe, the world map on its own, you discover that we have nations as a polygon. But under these nations, states within the nation does not appear. They appear as a point data because the scale is this small scale map. But when it comes to large scale map, all those little things that disappear before comes up. Next. Data structure. Data structure is the logical arrangement of data as used by a system for data management. The representation of data model in computer form refer to what we refer to as data structure. And our data can be organized in different ways. The most common among them is what we refer to as relational database structure. Relational database structure. Relational database structure, which is in form of tables and columns. We are familiar with this kind of data structure. We are highly familiar. We use it on a daily basis. And the characteristics of relational database structure are each row, core record, or tuple correspond to a complete set of data about an object. each row, it gives you complete information about an object. For example, the one you are seeing there, the first name, the last name, major, and birthday. When you look at the row gives you complete information. That's one of the characteristics of relational database. Each layer can be independently used and saved. Each layer on a relational database can be independently used and saved in the sense that if you are interested in the column of first name, you can access it. If you are interested in the column of birthday, you can access it independently without any stress. Each column within a record gives a different kind of data information about the object. Hence, the columns are called the attribute or field. Each column gives you new information. Column 1 here is giving us the first name. Column 2 is giving us the last name. Column 3 is giving us the major. And the column 4 is giving us birthday. So each one, this column, gives individual a different information. And that is why we refer to it as an attribute table. Each field or column is given a label or a tag. Each field or column has a title that differentiates it from the other field. And then we have the next one, which is a hierarchical database structure. Hierarchical database structure, which may do as of kind of flow chart. That one is more or less like a flow chart, or directed or directional graph. I'm talking about the hierarchical database structure now, the next slide. Hierarchical database structure is an extension of relational data storage, but can be linked on the basis of parent-child relationship. Parent-child relationship. And we have some characteristics of this database too. The apex of the hierarchy is called the root, the topmost part of the hierarchy. For example, the cell representative now, that is the root. And it's also referred to as the parent. You can call it the root or the parent. And then each succeeding level is called element. Any other thing under the parent, we refer to them as element. Customer contact 1 is element 1. Customer contact 2 is another element. So we refer to this one as children. They are children. And then an element can only have one parent or can have several children. Customer 1, which is an element, only have one parent, which is say representative, but have children under it. We have product line 1 and we have product line 2. So children are permitted to have as many children as they want, but they are only entitled to one father or one parent. And another characteristic is that it's not possible for an element to have more than one parent. I've said that. You can't have more than one parent, you can't have more than one father. Then we have another type of database structure, which is referred to as a network database structure. The next slide, please. Network database structure. This one is more complex, and we refer to it as many-to-many relationship. Here, children are permitted to have link. In a hierarchical database, they are not permitted to link together. But here, they can be linked together, and then there's less redundancy, less inefficiency here. Linkage information is more complex and more tedious to construct. It has a link from child to parent, and it is an improvement on the first two types of database structure. And lastly, on database structure, we have what we call the object-oriented. Next slide. Object-oriented database. Object-oriented database is just an improvement on the network database that allow you to attach graphics, videos, photograph, audio to your feature in the system, of which when you click on any of your feature, your feature can also display video, it can also display photograph. For example, now, your university there, if it is captured in a GIS network, the photograph of the entire university can also be captured, By the time I click on the university coordinates, it will also display the university structure. Most of us who are used to hotel and tourist centers, when you want to book online, when you click on those things, it displays pictures and videos to you. So that kind of storage is what we refer to as a object-oriented kind of database. Next slide. All right. Then we go to the next topic, which is spatial analysis. Spatial analysis is what gives GIS software a leverage over every other software, because it allows you to carry out analysis in order to solve human complex problems. Just as I have told us earlier, there are a lot of human complex problems, ranging from one disaster to another, flood, health issue, and all manner. So geography information system give you the tools through which you can manipulate to solve this problem using spatial analysis. So therefore, spatial analysis involves examining the location, attributes, and relationships of features in spatial data to understand patterns, trends, and phenomena. It is a core function of GIS and encompasses a variety of techniques to analyze geographical and spatial data, which include the following. We have what we call overlay analysis. Overlay analysis in geography information system is a technique used to combine multiple spatial layers to produce a new layer that highlights the relationship between them. It's a powerful tool for spatial analysis, allowing users to compare and analyze the spatial interaction between different data sets. For example, now you are in Indonesia there, and you want to do overlay analysis on the population and the rate of crime. You have a layer that contains the population that tell you the rates of crime within the city. So if you want to check, maybe population is having impact on the rate of crime in the city, then all you need to do is to put the layer of population in those areas, maybe each of the states that the law enforcement agent has given you information. So from there, you can see the states, the population of the state, and the rate of crime. And then you begin to think, is it because of the population we have the higher population? The rate of crime here is high. Why? You put the population data on it. Oh, the population here is too much. Maybe one of the reasons why we are having high rate of crime. So overlay analysis allow you to put different layers together in order to come out with new results. Then example of overlay analysis include intersect, union, difference, and clip. Then number two kind of spatial analysis techniques is what we refer to as proximity analysis. Proximity analysis in GIS is a spatial analysis technique used to determine the relationship between features based on their distance from one another. It helps in understanding how close or far different spatial features are, which is crucial for decision making in various fields like urban planning, in architecture, environmental management, and transportation. And a good example of this kind of proximity analysis is buffering, distance measurement, near analysis, Cartesian polygon, and the rest of them. So this one will make you to come out with something reasonable, especially when there's, let's take for example now, you have a river that always flood yearly. All you need to do is to buffer the river maybe 100 meters away, 200 meters away, to know the area that the river, the extent of the flooding. And then by the time you know the extent of the flooding, you can use this buffer analysis to advise the government to take decision. Okay, after our analysis, we realized that the river, year in, year out, always flood 200-meter apart. So therefore, anybody living within 200 meters to the river should be relocated. And people should be discouraged from living within this zone. So those are the kind of analysis you can do with proximity analysis. Next slide. And then we have what we call the spatial statistics. Spatial statistics refer to a set of techniques designed to analyze spatial data, taking into account the location, arrangement, and distribution of features in geographical space. This method helps us to understand pattern, relationship, and trend in spatial data that are not readily apparent through basic visual analysis. And a good example of spatial statistics is spatial autocorrelation, spatial interpolation, hotspot analysis, spatial regression, and point pattern analysis. All this one will help you to take decision. When you engage in these spatial statistics, then you can see the trend, what has been happening for the past 10, 20, 30 years. And then you can even do projection of what will also happen in the nearest future, and then take informed decision. So those are the major type of spatial analysis techniques that we have in geography information system. Next slide. Then some common challenges when you are performing spatial analysis in GIS. One of the challenges is what we call data quality. If you don't have good data, you will not have good results. Another challenge is scale issues. Conversion of scale, changing from one scale to another, can also affect your results. Then projection and coordinate system. We have to make sure that our projection and coordinate system of all the data we are going to use are in the same coordinate system, or else your features will not overlap. They will not be able to sit together. And if they are unable to sit together, you will not be able to do your analysis. Next. However, there are a lot of fields where you can apply all this analysis. For example, spatial statistics can be applied in public health, that is mapping and analyzing the spread of diseases, identifying at-risk area that are prone to risk. It's also good in urban planning, evaluating land use pattern, assessing the impact of new development, and optimizing placement of infrastructures. And when we come to issue of proximity analysis, is also applicable in urban planning, analyzing the proximity of residential area to schools, parks, and public transportation. It can be used in environmental management, assessing the impact of industrial facility on nearby natural resources or residential features, and many more other places where you can apply all those spatial analysis techniques. We go to the next one, talking about some advantages of using GIS. When you are engaging the use of GIS, number one advantage is that it can assist you in assessing the extent to which a problem impacts a region or a community. It can help you. You can know the trends that is going to come, and you can know the event that has passed using all this spatial analysis method. It also makes clear the connection between various population, factors, or problems. Understanding how different elements influence one another is frankly made much easier when one can visualize it. When you can see it as a graphic, you get the understanding better. And that is what GIS can offer you. Number three, It can demonstrate how different an issue affects different population or geographical area. This can be important information for a number of reasons. It can pinpoint problem areas or population, giving clue on the origin or causes of condition, and suggest means of addressing the problem. Number 4, it can pinpoint the precise area in which you should focus your effort. There's that area where you need to focus your effort. If you are concerned with HIV/AIDS, for example, the prevention of AIDS, GIS can help you to identify area where the population is at the highest risk and where outreach, clinic, needle exchange, or other preventive measure should be located. So it can help you to pinpoint the precise area where you need to focus your effort. It can also help you better understand the area or community in which you are working. You are working in a particular place, it can aid your understanding of your neighborhood. A GIS map has the capacity to display a lot of data at once. So with this information displayed at once, then you can understand your community more than when you use ordinary paperwork. More also, it can allow you to isolate and examine individual aspects of the situation or area. It can allow you to isolate and examine individual aspects of the situation. By choosing layer to display, you can look at the interaction of various pairs of factors or just look at the geographical spread of an area. So that is another opportunity. It can help you to isolate a feature and study it and come to conclusion. It can also help in designing, implementing, and evaluating intervention. After your analysis, you can, it will enable you to plan and then also guide you in your designing, implementing, and evaluating your intervention. And lastly, it can help you to show changes over time. Next slide. Changes over time. Then, coming to geography information system, we have what we call cartography and visualization. That has to do with map. What makes your map unique? What are the things that make your map unique? When you draw a map, it must contain title. Your map must have a title so that anybody that have access to it will know what your map is about to tell. What your map is talking about. Your map must have a compass rules. That's what we call direction or orientation. The 4 cardinal points, you must show an arrow telling us the northern focus so that anybody handling the map will know how to position it well. Your map must also have symbols. Symbols, pictures are used instead of word, and which you now lead to the next one, which is legend or key. All the pictures, all the symbols you use, you will use your legend to explain them, telling us what the symbol stands for, what the colors stand for. Then your map, a standard map must have color, highlights important or different information to help interpret the map. Then your map must have scale. Scale shows the proportion of map to real life. The scale of the map means the ratio between the actual distance on ground and the distance showed on map. So if you produce a map in Indonesia and you put a scale there, me that is in Nigeria, as long as you put the right scale, I will know how big the land area of the map is in the real world by seeing the scale. And then grid reference. Grid reference intersecting line to help locate specific places on map. So these major points are very, very crucial when you are producing your map using GIS, because it will aid in the understanding of what you are trying to put across. Next slide. GIS application area. GIS can be applied in various fields, in geoscience, in business, oil exploration, tourism, remote sensing, geology, geophysics, civil engineering, urban and rural development, flood and disaster, image processing, natural resources, environmental, planning, administration, and management. But because of this course, we will limit it to 2 areas. Next slide. 2 areas of focus. This is more, this one is the what we refer to as AEC, BIM GIS. AEC means engineering and construction. Engineering and construction. BIM, somebody has dwelled over that one. I'm too sure now you have knowledge of BIM. That is building information modeling. And then the last one is geography information system. So these 3, the integration of these 3, that is BIM and GIS, is essential for AEC projects because it geo-enables system to power workflow of ASC during any phase of the project lifecycle, from planning and design to construction and operation. BIM provides us with the detailed visual representation of design assets, along with the associated detailed information about those assets. Geography information system will give you the attribute table of those assets. So the combination of BIM with GIS data become more potent because it provides information about assets in the real world and their location contents of the building and natural environment. When you produce your architectural work, all you need to do is to use the GIS to put it in the real world location where it's supposed to display. And by placing it in the real world location, you'll be able to see the structures beside each of your architectural work, and then this structure will determine how you are going to remodel or alter this your architectural work in order to suit the environment where it is being located. Next slide. And therefore, we have this in stages. The first stage is the planning phase of the project. A good example of BIM and GIS integration can help us to answer questions such as, how will this design impact the community? How will it impact the community? You want to set up for example, a school in a particular area. Then you import the project, the location of the project, where you want to, the new place where you want to site the school now. You put it in the community to see where it really exists in the real world. And by placing it there, you'll be able to know how does this new project, this school that I want to site, how does it interact with existing utilities? Oh, how many roads are already existing in this place? Do we have infrastructural facility that will support the location of school in this place? Because you are seeing the environment and you are seeing the place you want to locate your school. So from there, you'll be able to answer a lot of questions. Oh, if we are to site these schools there, then we will need more roads to ease out the traffic. If we are to site this school here, we need to connect with the National Water Board so that there will be enough water for the student. So this one is giving you the opportunity to interact with your environment, even on your system, without you necessarily going out on the field survey. Then we have another one, which is design phase of the project. GIS data integration with BIM model using Autodesk applications such as a Rift file contain georeference information. And it is becoming more and more common for architects and engineers to assign real world, that is geographical coordinate, through the Rift survey point and project-based point parameters. This coordinate, when present, can integrate and place the model in its correct location, just like the example of setting a new school in an environment that I gave you earlier. So it will help you to set it in the real location. This coordinate, when present, can integrate and place the model in a correct location, which will help to visualize design of buildings and infrastructure along the built and natural environment represented by GIS. And this one will enable you to take informed decisions as per your project. Then the next one, which is construction phase. Construction phase. Let's go back. Yes, construction phase. It is essential to monitor real-time progress with reality capture data to compare directly against the BIM data to help understand how an asset was designed, versus constructed, and detect issues along the way through collaboration of system and teams. This helps us to manage cost of supply, keep your construction crew safe, and relay information to all teams without information loss. That is when you are in construction phase, because everybody will have access to the map and everybody will know what is going on. And then the final phase, which is final phase of operation and maintenance. We essentially have a digital twin of our projects that can be maintained with real-time Internet of Things to assess performance, receive alerts from sensors, and schedule or monitor innovation that happen not only at the scale of building, at the road, rail network, and also the scale of the entire city. Next slide. Talking about GIS application to heritage building preservation. So far, that is the focus of this workshop. GIS help you in documentation and inventory management. Creating detailed records. GIS is used to create detailed digital record of heritage buildings, including their locations, the dimension, the architectural features, and historical significance of each of the historical buildings. This digital inventory helps in managing and preserving this structure efficiently. Another thing is that GIS help mapping heritage sites. GIS allow you for the precise mapping of heritage sites, helping you to maintain an accurate and up-to-date database of all heritage buildings within a given region. Next. Another area of application of GIS in building, heritage building preservation is partial analysis and condition assessment. Condition monitoring, e.g. GIS help in assessing the current condition of heritage building. What are the state of those buildings by integrating various data sources, such as structural assessments, environmental data, and historical record. This analysis can identify areas at risk or deterioration due to factors like wearing, pollution, or nearby construction. With GIS database, you can assess this kind of information. Then risk assessment. GIS can be used to analyze environmental risks such as flooding, earthquake, or urban development pressure that may threaten heritage buildings. By overlaying hazard map with the location of heritage sites, conservationists can prioritize intervention. Next slide. Application of heritage building, GIS to heritage building and preservation. We have what we call conservation planning and management. Strategic planning. GIS in the development of conservation strategies by providing tools for spatial analysis and visualization. This help in planning restoration projects, determine land use policies around heritage sites, and managing development pressures. Also, zoning and regulation. GIS can support the creation of zoning regulation that protect heritage building by defining buffer zones. Buffer zone, giving a zone whereby people must not encroach, people must not come near, and controlling nearby development. GIS helps to ensure that the historical and architectural integrity of these sites are maintained. Next. GIS application to heritage building and preservation in terms of historical research and analysis. Reconstruction historical landscape. GIS can be used to reconstruct historical landscape and understand the historical context of heritage building by analyzing old maps, documents, and archaeological data. GIS help in visualizing how the landscape and built environment have evolved over time, how they look like over time. GIS can help you to produce it. We also have cultural landscape studies. GIS supports the study of cultural landscape by analyzing the spatial relationship between heritage buildings, archaeology sites, and other cultural elements, providing insight into historical land use and settlement pattern. Next. Public engagement and education, interactive mapping and visualization. GIS can help you to create interactive maps and visualization that engage the public in heritage preservation. This tool can display historical information, virtual tours, and 3D models of heritage buildings, making the heritage more accessible and understandable. GIS can produce a story map for you in that respect. And then storytelling and interpretation. GIS-based storytelling platform can help in interpreting the historical significance of heritage building by linking spatial data with historical narratives, photos, and multimedia content. Next. Tourism and promotion. Heritage tourism planning. GIS support the promotion of heritage tourism by identifying potential tourist routes, mapping attractions, and analyzing visitor trends. It helps in creating guided tours and apps that can enhance the visitor experience. It can also help in marketing and awareness. GIS-based tool can be used to market heritage sites to a broader audience, increasing awareness and support for their conservation. Next. Integration with emerging technologies. 3D modeling and virtual reality. GIS can be integrated with 3D modeling and virtual reality to create detailed digital reconstruction of heritage buildings. This model can be used for virtual tours, educational purpose, and planning restoration projects. And then we have GIS and remote sensing. Remote sensing and drones, when combined with GIS, like LiDAR and drones, can be used to survey and monitor heritage buildings from above. This allows for the capture of high-resolution data, which is essential for detailed analysis and documentation. Next. It can also be used to support for legal administrative process, legal protection and documentation. GIS can support legal effort to protect heritage building by providing evidence of their historical significance and current condition. This data can be used in court cases, for listing building on heritage registers, and for enforcing preservation law. And grant application and funding. GIS data is often required for grant application related to heritage conservation. You are looking for grant from government or world organization, you can use GIS to get it. By having detailed maps and spatial analysis, can strengthen application by demonstrating the need for funding and the potential impact of preservation efforts. All these are application area of GIS to heritage building preservation. Next. And then quickly, I just introduce you to GIS practicals or the little we can achieve. Talking about GIS practical, talking about the interface. If you have a GIS app on your system, when you open it up, when you launch it, this is what you see. This is what we see. And then we have what we call the menu bar at the topmost part of the software. And just the topmost right hand corner, we have where your title will appear. The title of the project you want to do, when you have given it a name, it will appear there. And then just below the title, we have the menu bar. The menu bar that consists of information on file, edits, view, bookmark, insert, selection, geoprocessing, customize, and window. Under each of these, we have a tool, a drop-down tool under file, like opening, saving, printing, and hard data. Under edit, we have like redo, undo, copy, paste, copy map to clipboard. And then under feed, we have what we call menu, field data, layout view, graphic, report, and data frame properties. Under insert, we have menu, we have data frame, text, legend, not arrow, scale bar, pictures, objects. Under geoprocessing, that's where we have our major tools like buffer, clip, intersect, union, merge, and we have what we call ARC toolbox. That ARC toolbox contains all the tools you need for any analysis. Then customize, they're talking about toolbar and extensions. And last, second to the last is window, magnifier, viewer, table, and content. And then the last is help, which help you to go to the website for any information or any area that you are not clear to get better understanding of the functionality of the tools. And just below the menu bar, we have the toolbars. The toolbars are shortcuts to some of these tools under the menu bar. So instead of you navigating through the long journey, you can easily pick any one of them here and use as occasion may demand. And one thing with GI is that in case you are looking for any tool that is not here, all you need to do is just to right-click on the menu bar. When you right-click on the menu bar, you'll be able to see other tools that are available that you can use. All you need to do is to check it. When you check it, it will display on your view. Then we have the map view. The map view zone is what is showing us what we are doing. It displays whatever analysis or whatsoever work we are doing. And we have the layer 2 panel that is showing you all the layers that are displayed in the map view. And you can uncheck and check in case you want to be off or you want to be on. And lastly is the status bar, telling you about the coordinates and all sorts, the scale below. That is how the interface look like. So I will encourage you to, on your own time, to go and explore and check more, to know more, interact with the interface, to do better, and then try to do one or two things on your own. So the next thing is the future trend in GIS. Can we proceed to the next? I'm just giving the breakdown of this. The interface, what each of them contains. Then one of the menu bar, the toolbar, then hard data. The hard data tool is what help you to import data from your system to the map in order for you to work. I will try and see if I can share my screen with you. Then if can just bring out a map, georeference, and equally digitize for you to know how to go about it. Then let's go to the trends. The next slide. The next slide. Go on. I've explained all this. Yes. The new trend in GIS. The new trend in GIS now is integration with big data, AI. Then the 3D GIS and urban modeling is another trend. We have the web GIS, and then integration with Internet of Things and real-time GIS. We had advanced remote sensing and health observation is another trend. We have augmented reality, AR, and virtual reality, VR. We have what we call open data and crowdsourcing. Then enhance geospatial data privacy and security. We have the spatial data science and analytical customized GIS application. So these are the new trends as far as GIS is concerned. So you can see that GIS is growing year in, year out. And the time will come that if you don't know about GIS, you may not be able to do anything as far as education is concerned, because GIS is virtually taking over every aspect of education. Next. Thank you for your time. Terima kasih, bayang bayang. Thank you. So let's see if I can share my screen with you so that I just show you how to add the data and then do on-screen digitization. Let me try. Can you reconnect me back to my screen? Let's see. Yeah. Are we good to go? Now you can see my own ArcGIS. I'm using ArcGIS 8.2. So this is where the title will appear, but currently we don't have title because we have not stored any project. Talking about the file, the edit, the field. When you click any of these, there's a drop down. So all these things, I want you to explore it at your own time. You go through them and try to work with each of them and see what you can do. Then, in case you launch your Arc map and you are not having a particular tool, just right-click here. When you right-click, there are a lot of other tools. There are a lot of other tools that are not there at my display. Okay, don't worry. So if you find out that any of your tool is not on display, all you need to do is to check it. When you check it, it will display. When you uncheck it, it will disappear. So this is very, very important for you to know. Because I once appear, when I was a student, I once appear in a test, and our lecturer removed all this without telling us. And he gave us 15 minutes to carry out an assignment. Unfortunately, we know how to do the assignment, but we cannot find our tool. So we scored a 0. It was after the test he now told us that, look, next time when you don't see your tool, right-click and check the appropriate tools that you needed to work. So that's why I'm giving you this information. I don't want you to have made the same mistake. So when you go for interview, some people can intentionally remove those tools from your field. So when you don't see them, just right-click on the menu and then check any one you need, and it will appear on your screen. So here I have one map. I have a map, one Nigerian map in one of my folder here. So let's quickly bring it out and see how to go about it. I want to show us how to georeference. Georeference means you attaching the real world coordinate to your map. Because most of the time, the most challenge we have as GIS experts, we don't have access to data. So we depend on secondary data most of the times. For example, you want to work, I want to work now with Nigeria, Nigeria as a whole, and I need Nigeria map. I want to digitize the states in Nigeria. In Nigeria, we have 36 states altogether. So I want to create my own digital map from an existing map. I have an existing Nigeria map, which I scanned into my system. So when I have Nigeria map, all I need to do is to scan. When I scan into my system, from there I can produce my own digital map. So I have such a map here, Nigeria map. So all I need to go is to go to Add, this Add button, navigate to my folder, and I add the map to the screen, to the map view. You can see, this is Nigeria map. But this map, before the software, we understand where this map exists in the world, I need to register it. And how do I register? By inputting the real world coordinates. Where Nigeria exists in the world, I need to put the coordinates. That's what we refer to as georeferencing. So it will give the understanding to the hack map where this Nigeria is existing in the real world. Without that, the system will not be able to work anything with me. So therefore, this is my georeference tool. Let me remove it so that you see. You can see when I uncheck this one, it will disappear. So now that I want to georeference, I just need to right click, look for georeference, and click for the tool to do what? To appear. There are a lot of tools here that if we are to check everything, this place will not be enough to contain them. So that's why it is limited. So anyone you want to use part time, you go there, bring it out, and make use of it. So now I want to use georeference tool. So this is add control point. However, anything you want to add, you want to georeference, you must know the coordinate or the coordinate of important feature in those areas. So like me now, I knew the coordinate of the four corner of the nation. So I'm going to use the four corner to georeference this map. So add control. You can see that my cursor has changed from palm to plus. So I will take it to the place where I want to add the control point, this extreme hand. When I get there, I click and right click. When I right click, it's telling me to input the X and Y. X and Y. The corner, this corner, X and Y, X stands for longitude, Y stands for latitude. My longitude here is 3 degrees. My latitude here is 14 degrees. So I will say, okay, that one is done. Then I come to the second stage. I will do the same. Click. Input. My longitude here is 15. And my latitude will remain 14. Still the same line. Okay. Register. Then I will come to the turn point. Input. This is the hex here is 3. The vertical line. And then the latitude is 4. Okay. Then the last point. Input X and Y. This one will be 15 again. And this one will remain 4 again. Then I will OK it. And then come here and said, update your referencing. If you don't update, it's not saved. So when you click on update georeferencing, then it will update it for you. And that is what we refer to as georeferencing. With this, we have georeferenced this particular map. Now, having georeferenced this particular map, then the system now is aware of the location of Nigeria in the real world. So I can now digitize any state of my choice out of this 36 states. And how do I do that? I go to my catalog where I have my folder that I name Indonesia. Then you right click and then new, a new shape file. The new shape file is asking me, what is going to be the name of this new shape file? Let me say Kebbi State or Niger State or any of these states, just in order to beat time. Okay, let's say Kebbi State. Kebbi State. Then, remember, a feature can be a point, a line, or polygon. So what am I trying to do? I'm trying to do a polygon because a state starts from a point and ends in that particular point. So it's a polygon. So I'm not going to select point. I click here and then click on polygon. And click on polygon is telling me the unknown coordinate system. Then I can here edit my coordinate system to projected. So you must also know your coordinate system. UTM, WGS 84, Northern Hemisphere, Nigeria is in zone 32, not 31, 32. So I can use any of them. I can use 31 knot, I can use 32 knot. Then I say, okay. And then, okay. So set. You can see it has applied my tag catalog as Kebbi.shape. So I select it and then come to the editor here and say, start editing. Then this thing will be highlighted. Sorry, the system is a bit low, too many things in the system. Then this is my create feature. I want to create a feature, a polygon feature named Kebbi. Then I click on it and then pick my polygon tool. You can see, and this is Kebbi State. So I click from the starting point, and then what I'm doing now, I'm digitizing. I begin to move along the line. Follow the line. Follow the line gradually. Then back to my starting point and double click. You can see. Then I will say, stop editing and save editing. Yes. So go to your content table. Kebbi is now digitized. Look at it. So I now have a digital map of Kebbi State, one of the states in Nigeria. Then I can go to symbology by changing it. I want it to be hollow. I just want to see the boundary. And then let me change the figure. You can see. So remove this one. This is Kebbi State for you. When you want to do more, you put it. So this is what we call digitizing. And you are all familiar with scanning. So scan the object of interest to your system, bring it to your GIS environment, then digitize the feature you need, and then you start to work as the case may be. So I want you to explore more and more on your own. And if you have any challenge, you can still contact me even after the lecture through your coordinators. They will link you up to me. Thank you, Terima Kasih.
Yeah, thank you very much to Dr. Jabhat Jaramola for the very insightful and enlightening presentation today about the geographic information systems. And Dr. Jaramola has showcased some various aspects on how the GIS could be applied in various field of topics and research. And I think it's very interesting to hear from him about this knowledge today. And before we are going to accept the question from the audience, I might have some question to Dr. Jabhat Jaramola. So probably one of my very main question is sometimes when we are working in, for example, like certain projects or spatial space, we need spatial data faster. And based on like the advancement of recent technology, sometimes data could be obtained by some cloud system based, or there might be some provider for digital spatial data that we could obtain immediately without have to doing the process manually. So my question is, do we have like a particular way to maybe to more automate the process on how we get the spatial information such as the line, graphic, or vectors in this software? Is it like open access for everyone to probably make the data that we could obtain, it's become more faster without having to do it manually? Or it is something like accessible for everyone, or maybe there is some like I don't know, subscription, or it is like open access, like geographical data, as we might know. Maybe now we have some others tools like Google Earth or Google Maps that could be integrated to this software based on cloud systems without having to do it manually, that you have shown us today.
Yes, sir. There are data that are automated, and there are those that you have to do manually, especially those of them in the Western world. United States, UK, they are lucky to have those things in their archive. And then all those things are easily available for them or for their community to use. For places like Nigeria in the third world, we don't have those things. Especially, some of them are not up to date. So this organization may give you something, but maybe 10 years backward, 15 years backward as open access, free. But the current one that you need for your analysis that is current, you may not get them, except you have to subscribe and pay for it. Just as this software now, even the hard disk is licensed. It's licensed. But we have a Quantum GIS, that's QGIS, which is open access. And they are performing almost the same work. So there are a lot of data that are available free, and there are some that you need to pay for before you can get them. And there are some also you can download from the internet, from the cloud, especially through Google Map. Even your GIS is linked to Google Map. So you can easily have access to check, especially those things that are free, you can get them. But the one that you have to pay for, you just have to pay for, especially developing countries. There are things that you just have to do by yourself. Thank you.
Right. Okay, so now probably I would like to continue this session to open for the audience or participants today. If from the audience has some question, you can ask directly to Dr. Jabhed Daramola by using the raise hand feature on the Zoom application, and I will allow the participant to ask directly to Dr. Daramola. Any question from the audience? Okay, before we come to the direct question from the audience, I think I would like to read some written question in the chat box. And these questions are coming from Suchi. He asked about how can the GIS can be used to identify and prioritize heritage buildings that are most vulnerable to natural disasters or human-included threats, such as climate change and else. I mean, probably her main question is about how to integrate the GIS system that could be analyzed for such a heritage building or human climate related case.
Yes, this I've also explained in the course of the GIS application to heritage building preservation in terms of risk assessment, that GIS can be used to analyze environmental risks such as flood, earthquake, or urban development pressure that may threaten heritage building by overlaying hazard map with location of heritage building. You have your heritage building, you have the location of your heritage building is already on your map, you have it as a map. Then you have another map which we refer to as hazard map, maybe the flood map. So all you need to do is to put the two maps on each other. The flood map will show you the extent of flood within the heritage building. From there, you'll be able to buffer it and know maybe the heritage building fall within the buffer zone of the flood. So if it is within the buffer zone of the flood, then you need to now derive another map showing the level of encroachment of the flood into the heritage building. And from there, you can now advise the government on what to do or the right thing to do. It's the same thing as having something like typhoon or cyclone. You know the path which it follow in case there's any heritage building along that path. All you need to do is to overlay. That's why I took my time to explain all those kind of analysis you can do using GIS. So this kind of a thing, overlay operation, is the best thing to do. That one will give you the opportunities to see the heritage building and also give you the opportunity to overlay the hazard map on it, depending on which hazard that is prevalent in your zone. Then from there, you'll be able to take informed decision.
Yeah, so maybe for the following question about this issue, I think sometimes as a human, it is a little bit difficult for us to digitize the data manually. Is there any particular tools that we may work with satellite-based system to integrate or to obtain our data in this process, or it is only like for the direct observation or manual observation on the location? I mean, how we could make the data of this heritage building, for example, or climate or flood and disaster to be more reliable and to be more accurate. I mean, how we can make this all of these things to be more precise, reliable, and accurate, Dr. Dharamala?
Yeah, there are a lot of digital data, and we refer to them as raster. You know, I mentioned it in the point of the lecture. We call them raster data. Those raster data are digital in nature, mostly collected through remote sensing and in different organizations. The land, we had a land, so depending on what you are working with. So, and when you have a digital data, which is a raster data, it makes your work easy because so you can import them directly to your ArcView software and do along with it. Special tools to carry out raster analysis. When you look at that Arc toolbox, maybe later you just take your time, open the Arc toolbox. It contains a lot of tools. Vector, the one that you can use with raster. So you can get a ready-made map data from the satellites that you can import directly to your system, and you do your work without any stress.
Right. Okay. Yeah, I think because some of the participants or students today, they might not be really familiar about this software, and sometimes I'm thinking that it might quite challenging to obtain a lot of data at the same time simultaneously. So we might need some like remote tools or like certain tools that we have to put on the location, perhaps to create the map, or probably we could access some institutional like weather station or remote satellite base that some organization might provide in certain areas or certain region. I think that might hopefully that have answered the questions. Any other question from the audience?
Some of those data you can get freely, but the major disadvantage you have is with free data is that some of them are not up to date, just as I've told you. Works on requires soil. I require soil data. I require the climatic data. I require land use data, and I require the digital elevation model of my area. Four things are very key to my study. And then at the end of the day, you discover there are 10-meter resolution digital elevation model. There are 30, there are 90. Unfortunately, during my time, I could only lay my hand on 30. That is the only free version. The 10 is beyond my reach. I can't afford it because I have to pay for it. So those are the challenges we are having when it comes to data. But when you have your resources, you can pay and you get data. And I want you to believe with me that the 10-meter resolution data and that of 30-meter resolution data, the result will be different because that of 10-meter is high resolution. It gives you details than that of a 30-meter. So those are the challenges. So some of those organizations will offer free thing for you, but what they will give to you may not give you the best result as you desire. But because you are limited, then you just have to go with what you have. That is it. But when you are financially capable, then you can get what you have by paying and then get the correct data for your analysis. But if the government is up to the task, most of these things in the United States are free to their citizens because the government have them in their data pool. So all you need to do is just go there, download, and then make use of it. But the third world country, those things are absent. Our government are not having those data as we require. So the awareness needs to be created so that our government too can begin to wake up and do the needful and then get this database stored so that anybody that needs to access any one of them can easily get them without any stress. That one will go a long way in helping our generation. Now that the whole world is tending, every course is tending towards GIS. So GIS has future. Yeah, it has future. So the earlier, the better the leaders of those of our nation realize it and begin to do the needful, the better for us. Because even now it is being used to generate income to the government. GIS, like in Nigeria now, we have a lot of states who have set up the Ministry of GIS because they are having money. They use it to produce CFO. It's giving them good money. When they digitize the land, they allocate it, and then they have your database, they have information concerning every parcel of land, and then you pay, and then they release the land for you with your CFO. So it has eliminated a lot of old and former way of doing things by bringing new idea, and then you discover that government these days are now trying to embrace GIS technology. So if that is done by our leader, it will go a long way to help us.
Right. Okay. While waiting for another question from the participants, I think we have a new question in the chat box right now from Nazla. And she asks about, based on Dr. Jamala Daramola, based on Dr. Daramola experience, between ArcGIS and QGIS software, which software is the most detailed and effective to use in this heritage case?
Well, you agree with me that ArcGIS is still the best. ArcGIS is still the best but it's expensive to acquire.
Right.
ArcGIS is still the best.
Yeah, so probably
But
some
institutions, wait, institutions, ArcGIS have, they have licenses for institutions that, you know, that take care of students. So if your university subscribe to it, then the student will have access to use it. And they will have access to the full version, you know, than getting it individually. Like when I was in Malaysia, UKM subscribed to it and I have access to use it. So if they have an institution-based subscription license that help the students to access the software and to do whatsoever they want to do within the time they remain your student, no, not after graduation.
Yes, so maybe some of students here are not familiar into more details about this two software, because in architecture we might dealing in some small scale zone of project. I mean, in terms, when it comes to like in, if you want to present some macro projection of our site or spatial geographic presentation, this GIS software could provide, give the information about more macro situation in our architectural site context, maybe. Yeah. So, I mean, I would like to continue this discussion to perhaps raise some question to Dr. Daramola. So my another question is, sometimes as a human, we are tempting to obtain a lot of data, right? Because a lot of information that we need to provide in our system, such as extracting, not only extracting the location and line or vector or 3D models in our software. And we could also, from your presentation, I have heard that we could also attach some attributes like image or videos or population data or traffic, transportation, and many other data. Sometimes we want to integrate them in one system, and it could be overwhelming sometimes to manage what data that actually we needed. So do you think like using this software, which could provide a very huge data like this, can be aligned with the computer capacity that probably some student might have some limited specification to run this software? I mean, what is the challenges of using this software when it comes to, sometimes we have a lot of different layers that we want to include to our software, and sometimes it's a little bit harder to catch up with on how our computer systems could run to this software. I mean, maybe you could tell us some of the experience on how you work with your previous project with this such a huge data in this GIS.
Yes, just as I mentioned, as one of the component of GIS, talking about the hardware. The hardware, there are minimum specification if you want to enjoy your work. A minimum specification of hardware you need to use, or else your system will slow down. You are clicking and clicking, it's turning and turning and turning. Why? Because the software have eaten chunks part of your hardware. It's taking it over. And one thing you have to understand is that hard disk data are space consuming, especially when it is raster data, images, they consume space. So that is why you have to look for a more better system, like maybe starting from 8 gig, 1 terabyte. ICO 7 will serve you better. But anything low, below this specification, as time goes on, your system will slow down. The speed will reduce because of the carrying capacity is having. So the more better your RAM is, the more better you enjoy your work. It will not slow you down. As you are clicking, it's responding. You click file, the drop-down lists are out. Anything you click will come out. But when the specification is low, then automatically it will affect your work. It will slow you down because it will take time for the system to respond. That's just the challenge. And that's why when you want to install this kind of software, make sure you have at least minimum software that can, minimum computer that can sustain your work, that will not frustrate you when you are doing any form of analysis.
Right. Yeah. So, yeah, I think when we are dealing with such a huge amount of data, probably we need to consider what type of data that we need to our project to probably simplify the process. And while waiting for another question, I think I would like to continue the conversation with something that I'm thinking right now, probably about for some cases, like for example, in our city in Medan, we are dealing with limited data because it's not really up to date sometimes, and sometimes we need to create the data that we need manually and do the site observation on site. And for example, like if you want to mapping the heritage site in certain particular area in the old city of our city, we need to see the actual location sometimes, just because there is no available online or website source that could provide the updated data for us. So based on this issue, sometimes we also dealing with some project in remote location, such as village or forest, or some of natural special data in our city that also might not readily available in any online source to get the data. Do you have some other experience, or probably on your previous project, on how to deal with this case to obtain the data in such a limiting environment, and how to optimize the process so you can get the optimum data that you want to get.
Yes. The facts still remain. Even when you have already available data, that's what we call grant treating as far as GIS is concerned. When you have data from the internet or from the cloud anywhere, it is your responsibility as the researcher to go to the field to check things out, to see how it is. You must have at least some experience, the practical knowledge of where you are working with, so that in case the data you are having is not in line with the practical experience on the field, then you can adjust. So that's what we call grant treating. So it is very important in anything you are doing. And today we have a lot of ways to capture futures. Even your mobile phone, you can capture X and Y coordinate using your mobile phone. There's one app we call GPS way. From there, you can go and take we call it GPS way. It has coordinates, GPS waypoint. You can look for it. You can download it to your phone. When you download it to your phone, you can take it to field. At least it will give you some. It may not order be 100% accurate, but at least it will give you something close to what you want in the field. So you can use it to get the coordinates of futures. Maybe along the river, you want to take the coordinate of a river, you want to bring it to your system, just use it at the starting point of the river. You start. When you study it, you can do it manually or at interval. And as you are walking, it's taking the coordinates. As you are also going along the meandering of the river, it's also going. So later on, you transfer the record to your system in form of CFC file, comma delimited file, because the ArcGIS can read comma delimited. Anything you are taking on the field, you must convert it to comma delimited, so that when you want to import it to your ArcGIS environment, the ArcMap will be able to understand and then read it for you. But when you store it in another format, when you open your system, it will not appear. But when you store it as comma delimited, when you open your system and navigate to the folder, it will appear. And from there, you can import it to your system and then do whatsoever you want to do. And outside this GPS waypoint, that's what we call handheld GPS. It's portable, just like your phone. We call it handheld GPS. That one too will give you some percentage of accuracy. But if you want to get the correct accuracy, you go for inferential GPS. That's the GPS that the surveyors use on the field. You can see the surveyors putting their GPS on a pavoter stand and then taking readings of any future. So that one is more accurate than this first two. So with this, you can take the measurements, the points of any data, either in the remote area, in the city center, or anywhere to do your analysis.
Yeah, I think this is a very interesting topic, probably for some student today's that currently studying architecture might using this software, and for some architectural urban context or urban design in the future. And from this session, we have some understanding about how powerful these tools could be applied and integrated in some of architectural or urban design context of project in order to make our analysis and our understanding or our interpretation about the spatial environment of our project could be more presentable and precise and reliable. And I think this is something that we couldn't ignore because sometimes if we build a project or a building in our city, sometimes we are dealing with many aspects like environmental aspect, like such as transportation, climate, topography, and many other things like heritage site or so many concern about the surrounding environmental analysis if we want to make our project if we want to produce a project that could gives the better impact to the surrounding environmental system. And I think we are now at the end of our session, as we also see that there is no other question from the audience at the moment. And I would like to maybe end this session by giving a really big appreciation to Dr. Jabhat Daramola for a very insightful and informative presentation. I hope this session could gives new knowledge or information on how this software or this geographic information systems could be integrate or to be intersect with some of architectural design project from the student. And to all participants, I want to express my gratitude and for your active listening and engagement for this very thoughtful question and discussion. Your participation on this session has made this event truly interactive, and hopefully you will find this session insightful. Before we close this session, I think I would like to invite the host to deliver the certificate to our speakers today. Thank you very much to Dr. Paramola as our guest lecturer today for the International Summer Course Architecture Universitas Sumatera Utara 2024.
Thank you so much.
Yeah.
Appreciate. I dropped the test link on the chat so they can attempt the test.
Right. So
yeah, the quiz.
Yeah, so for the participants, you might find the link that Dr. Daramola has provided in the chat box, and you might press the link to put some to participate the quiz or the questionnaire that Dr. Daramola has provided on the link, and Dr. Daramola will see on how the understanding of the participants today by answering the questionnaire that he has provided in the chat box. And I will encourage to all participants to fill the questionnaire and to participate to the questionnaire as the last part of the workshop session today. Thank you very much for Dr. Jaramola to that all of your effort to make the presentation today very interesting and engaging to our participants today. And maybe if for the audience, if you have any like personal question or personal thought to Dr. Jaramola, you might contact him through you might be possible to feel free to continue to the discussion by reaching out to Dr. Jaramola in other way of communication such as email or online communication, and continue the conversation if you might have any interesting question. And once again, thank you very much to everyone, and a very big appreciation to Dr. Jabhat Daramola and all the committees of the International Summer Course today. And I really hope that you found this session as enlightening as I did. And have a good afternoon to everyone. And we are looking forward to seeing you at our next event or another session. Thank you.
All right, thank you for Mr. Mansuri. And as a token of appreciation to Mr. Ahmad Mansuri, ST Arts ME, for moderating the second session.
The International Summer Course Architecture 2024 Committee presented a flag of appreciation to Mr. Ahmad Mansuri, ST Arts MT. Thank you, Mr. Mansuri.
Thank you very much, Dr. Jeps and candidate Dr. for Ahmad Mansuri to be moderator for today lecture. So highly appreciate for you all. Thank you so much.
Yeah, thank you very much, Dr. Isnan, and good luck for the rest of the event that's still happening right now in this International Summer Course Architecture USU 2024.
Yeah, Doctor. That Mr. Ahmad Mansuri is live from which city are you studying?
So I'm currently
Pardon?
in Liverpool, University
Liverpool, yeah. So he live from that's Liverpool for moderating our lecture today. Thank you very much.
Yeah, it's such a great opportunity, and I'm very happy to be participated and contribute as a moderator today. Thank you, Dr. Isnet.
Welcome. Bye.
Bye.
All right. And just like that, we've reached the end of our Day 5 International Summer Course Architecture 2024.
But wait, Nine. Before we close today's sessions, I think it's time to remind some of students that will be going on to Milan some of the stuff that they need to bring.
Oh yeah, I heard that they are flying here tomorrow morning, yes? And I'm really excited to see them soon.
Wow, so I want to remind you again to bring your own tumbler and also the gift for the gift exchange party.
And you don't need to wrap it because we are gonna wrap it for you. And remember, just buy the stuff under $7 or 14 ringgit. And also don't buy something that expires in the near time because we want to treasure it forever.
And don't forget to bring your jacket.
Yes, bring your jacket because the class could get very cold. We've experienced it there and it was freezing. And before we end today's meeting, we are going to take some documentaries. So for all participants, please turn on your camera. For the first page, please turn on your camera. Tabik Imaro, Muhammad Azil,
Prinsa, Noor, and others. Okay. Please turn on your camera for page 1. We will take a picture in 3, 2, 1. Cheese! Okay, for the second page, please turn on your camera.
For the second page, please turn on your camera. Patricia, Nur Farah, Muhammad Rian,
Dania, Mushifa, Laura, Natasha, Rafi, Razan, Muhammad Rian, and others, please turn on your camera. Okay, we will take a picture in 3, 2, 1. Cheese! Okay, on behalf of the entire team, we want to say a massive thank you to everyone who joined us today. Your energy and enthusiasm made this program unforgettable.
Until we meet again, keep exploring, keep learning, and keep shining.
I'm Luis, and this is Ibel.
Hi, Ibel. And I'm Naya. Thank you, everyone, and take care. And you may fill up the present links right now.
Goodbye and take care, everyone. Happy Independence Day, Malaysia.
Ya, ada yang ngeloh.
Pancur sisa melameringis mo bagai turang ale merdida kalak mo bekel masada duan dando ale katita mo duan dando ale katita mo. Kijong